నాగులు బండి కావాలి. మీరు వాడడం ఇది కావాలంటే వాడతాను. ఎక్కువ వాయిస్ గట్టిగా ఉంటుందండి. బాగుంటుంది.
So, good morning, dear participants. So, today we are fortunate to have Dr. M. Suresh Garu from NIT Goa, Associate Professor. So, today he will discuss about the electrical vehicles and its applications. Please welcome Dr. Suresh sir. Now, the session will be taken over by the sir. You finalists. Faculty.
Good morning, Mananda. Today we are going to learn about at least EV, electric vehicle. What are the types are there? Okay. So what type of schemes are available? FAME India schemes. EV charging infrastructure I will try to tell you. And if time permits, we are having VTX topologies are there: vehicle to grid, vehicle to vehicle, and vehicle to load, vehicle to home. So when you connect VTX topologies, so what are all the converters and inverters required? Total charging infrastructure during VTX topologies also I will try to give you. Fine. And afternoon session, then there is 12 to 1 is I will try to discuss about 2 or 3 transaction papers are there of my students which were published in EVs, especially the standards EV charging infrastructures are there. There is VTX topologies. Based on this presentation, we are having there are 2 or 3 different papers are there. I will try to show you the papers. Then afternoon session, if there are PhD scholars are there, I will try to give you like how to write a research paper, where to publish. So each part I will try to explain it. Fine. So first session. So before going to EV, we should understand what is the motivation behind electric vehicles. Why we are going for EVs or why we are going for PVs. So the title itself what? FDP on which one? Design of controllers for microgrid and EVs. Fine. So we should understand why we should go for either microgrid operation or maybe EVs. Is it clear? So I will try to give you that. Then I will go in depth. First, I would like to thank the organizing committee and the management for giving me this opportunity. So let me go. The accelerated electrification of transportation is required. What is that? Accelerated electrification of transportation, charging infrastructure, 21st century grid. Remember these three. We are going to discuss about mainly these three. One is electrification of clean transportation. Second one is charging infrastructure. Third one is 21st century smart grid. These three are required for which one? Future proof of energy security and clean air objective. We need the clean air objective. We want carbon emissions are very less is required. Net zero emissions are required. For that one, what is required? Clean transportation, charging infrastructure, EV charging infrastructure. Then third one is 21st century smart grid. These three are the main key enablers. Fine. So how to achieve that? Let me discuss. So to meet that clean air objective, Government of India has initialized 2 main schemes were there. What is that? The first one is NEMP plan, National Electricity Mobility Mission Plan. Can anyone say what is that? This fourth session no on EVs. What is NEMP plan? National Electricity Mobility Mission Plan of 2020 they have introduced. Can anyone say? I want active participation. If you don't know, you raise me. I don't want passive participation. At least after completion of maybe 3 hours, you should go out of the room with delta X. Otherwise, traveling from long distance it is useless. So I expect from you active participation. If you don't know, you tell me. If you know, accordingly I will change my way of depth how much I should go. Fine. So what is NEMP plan? Can you tell me? Yes. National Electricity Mobility Plan. So that is, it aims to achieve the national fuel security by promoting hybrid electric vehicles. Fine. To promote the hybrid and electric vehicles, battery electric vehicles in the country, so the government has initialized what? NEMP plan. Fine. Is it clear? To support EV development, they have initialized NEMP plan. Second one is, so we need to do the grid modernization. You might have heard about grid modernization. Not only introducing EVs, we are having PV are there, photovoltaics are there, solar is there, wind is there. We are having renewable energy sources of PV, wind, isn't it? We are having now EV is there. Even we are having batteries are there. Try to understand. My motto is, or the Indian government motto is, to reach clean air objective. To reach the clean air objective, people are going with renewable energy. Am I clear? If we go through the renewable energy, what will happen? We can achieve the clean air objective. And microgrid operations also, why we are considering reason is, microgrid operation also required to meet the instant requirements of the people rather than acquiring the energy from one central part. So we are acquiring the energy how much is required from the in the form of microgrid. Am I clear? So NSGM what it says, grid modernization with the help of renewables existing, that can be wind, it can be solar parks, or it can be EVs, it can be batteries. What we are doing, smart meters are there, ICT protocols are there. So what we are doing, we are doing the grid modernization with the help of the existing components or existing technologies what we are having, with that we are doing. Finally, why we are doing that one? The reason is, through the renewable energy generation, we want to generate the power 500 gigawatts by 2030. Okay. So why we are going for renewable generation? As I said, clean air objective required. If I go with non-conventional, difference can you tell me? What is renewable? What is non-renewable? What are the things will comes under non-renewable? So, see, non-renewable in the sense, there are finite elements are available in the on the earth or inside the earth, so which will after certain use of time, so again we can't renew it. What will happen? Understood? So those are called conventional energy systems. Fine. But whereas renewable energy systems are, we are acquiring the data or we are generating the data with the help of the sources which are available freely. It can be sun, it can be wind, it can be tidal, it can be geothermal. Am I clear? Getting or not? So now what we are doing? So we are going to generate the power or through the renewable power generation, which are generated faster than the consumption. That is the basic. Am I clear? So renewable power generation of 500 gigawatt by 2030. So why we are doing everything is, reason is to reduce the carbon emissions and to improve the air quality. Clear? Our intention is clean air objective, national fuel security. So here what we are doing, clean transportation is required, charging infrastructure, 21st century grid required. Okay. So here two plans we have taken. NEMP plan to promote the electric vehicles, NSGM is integration of the grid. So third one is, when you are integrating, we are considering the renewables generation of 500 gigawatt. Why we are doing? To reach the carbon emissions, to reduce, to improve the air quality. Fine. Is it okay? Now, new entrants in the power sector are, we are having mainly, as I said, PVs are there, photovoltaics, which is nothing but solar. Second one is EVs are there. Third one is battery management system. And fourth one is smart meters or grid intelligent structures are available. Fine. So when you are having these ones, so first we should understand what is the smart grid vision. Fine. Before going to EV or microgrid, you should understand what is the smart grid vision of India. Can anyone say? Good. Transforming Indian power sector into a secure, adaptive, sustainable, digitally enabled ecosystem. Try to understand. We want secure power, we want adaptive power, digitally enabled, and sustainable power is required. Why? To provide reliable and quality energy to the stakeholders. You want reliable energy and you want quality power. Quality means clean air objective you need to meet. The main intention is quality power in the sense the clean air objective, and you need to maintain harmonic free energy you want to get. Okay. So when I want to get that, so what is required is the power should be secure. So how can I get the secured power? So we are using the smart meters, we are using the grid intelligence to make the system more secure. ICT protocols we are considering. How the system can be adaptive? So we are having bulk grids are there, there are micro grids are there are nano grids are there. I will try to discuss you that. So when you have a micro grid systems are there, when you are having a micro grid is there. So difference, can you tell me what is bulk grid, what is micro grid, what is distributed grid? Huh? Yes. Huh? Your title itself micro grid is there. That's why I'm asking. There is a bulk grid is there is a distributed grid is there is a micro grid is there. Difference, basic difference is what? Huh? Huh? Distributed is? Yes. See, bulk grid in the sense, if you want to generate, there are n number of PV panels are connected at one place, or there are n number of thousands of wind plants are connected at one place. If you are generating bulk amount of energy, it is called a bulk grid. N number of sources, it can be PV, EVs, it can be wind. More amount of energy at one particular place, if you generate, it is called a bulk grid. Am I clear? What is distributed? If you go to highways, there is throughout the national highways, you may observe there are windmills are placed across the roads. Have you observed? Along the path you are going, no, along the path when you are going, when you are traveling long distances, if you observe, what you will observe? Along the path there are some solar parks will be there. Mostly you will observe wind farms, windmills you will observe, isn't it? So when the power generated devices are, the windmills are distributed along the path, that is called distributed energy. What is microgrid? Am I getting or not? At utility level, if I connect n number of sources or more amount of energy if you generate at one particular place, that is called a bulk grid. Distributed grid in the sense, you are having n number of sources distributed periodically with some distance along the path. What is microgrid? Tell me. Name itself micro is there. Microgrid is small in nature. So at your organization, you are having what? Solar PV can be there. Small amount of inverter structures can be there. You are having normal grid connection is there. So one particular system consists of small amount of energy you are generating for the need of maybe residential, commercial or industrial level of need of only particular zone. Am I getting or not? To meet the requirements of the particular one area, that is called a microgrid. Difference, do you understand? Is it clear? So now what we are doing? So we are transforming Indian power sector into secure, adaptive, sustainable, digital enabled ecosystem. Security, how we are getting? By considering grid intelligent machines and grid intelligence as well as smart meters we are providing. So security you are getting. And next, adaptive in the sense, we are having solar systems, we are having windmills are there throughout the system, you are having power in the form of microgrids are there. So it is adaptive in nature, no? Automatically either you can connect or disconnect. It can be grid connected or maybe standalone it can work, isn't it or not? Getting? Am I getting? So the system is, the future smart grid should be adaptive in nature. Earlier what was the power? So when you are depending upon only conventional energy, there were power failures will be there. The people used to stay how? Without power also we used to stay. Now at each and every house we are having inverters are there. I mean, you have a continuous supply. So can you say that it is adaptive in nature now, future system? Now third one is sustainable. So when you consider any of the technology, it should be sustainable for longer periods. Sustainable means once if you design a power system, if you employ smart meters, if you employ any PV panels, if you employ any wind systems, it should be sustainable for more years. Today one technology is there, tomorrow again it is changing. No, it should not be. So today if I employ some particular algorithm or particular smart meters into the power system, so it should be sustainable for longer period, it should give the best results. Am I clear? So when you consider power system, you need to transform the Indian power sector into secure, adaptive, sustainable, digitally enabled ecosystems. Okay, for reliable as well as quality energy. Now, so what we are having, so how we can achieve that smart grid objective. So earlier what we were having? So we were having, this is energy network, this is your communication network. Here we are having generation, transmission, we are having distribution is there. So we are generating the power, we are transmitting the power, we are distributing the power. Am I clear? And we do have, these are communication protocols are there, wireless sensor networks we are having. Now what we are doing, so we are merging energy network with the communication network. If you merge communication protocols, or if intelligent systems, if you connect, or smart meters, if you connect with the grid, what will happen? Earlier we have only energy network is there. Now we are installing smart meters everywhere, and we are going to consider communication protocols throughout the network. By adding communication protocols or smart meters, what you can achieve? Not only security, real-time simulation is possible. What does it mean? At each and every substation, how much amount of power is generated, how much amount of power is distributed, how much amount of surplus power is available, or what are the voltage standards, what is the frequency standards, how much amount of, understood, no? P, Q, V, delta, each and every data of every node in the sense, every substation we can identify. Since we are having smart meters each and every place, we can do the real-time simulation. What is meant by real-time simulation? We can acquire the data from each and every field points. Clear? If you know, at each and every substation from generation to till distribution, if you install smart meters, reliability will be increased. Isn't it or not? Earlier, there were no smart meters. So, where you are having excess power, where you are having deficient power, you don't know anything. If you contact them through telephonic operation only, you will understand. But now, in the future, if you are going to connect smart meters throughout the network, real-time simulation is possible and reliability is increasing. Third one is network optimization is possible. How you can optimize? We are having ring main systems are there. Now people are talking about one nation, one grid. We are having southern grid, northern, east. Isn't it different type of 5 grids are available? Now what we are doing? The power is shared among the grids. Clear? So if we know from each and every substation or each and every point, if I understand how much amount of power is available, so what can be done? It can be, network optimization can be easily done. If network optimization is done, then I need, suppose suddenly load is increased, a dynamic loading suddenly after 10 years, no, the load will be doubled, electrical load will be, no or not. To meet that requirement, we need to go for installation of new power plants. Now, if I utilize best how much amount of power is existing with me, then no need investment on new power plants. Am I clear? So for that one, network optimization can be done with the help of by merging energy network with the communication network. Okay. So customer participation will increase, and even you can participate in the energy markets. So this is what. So we will see the first comparison of how the conventional grid was. So how the future grid will be. Then we will go in detail. So how the conventional grid. So it was electromechanical, isn't it? Conventional grid was electromechanical, and it was only one-way communication. So the persons used to collect the data. That's it. So it was a one-way communication, and power was generated centralized. Initially, the power was generated at one place only. It used to transmit. Clear? It was centralized generation. Very few sensors were installed, and manual monitoring, manual restoring. Manual monitoring in the sense, if they want to check any power failure, other things, people used to go and check where the problem has occurred. And restoration also, it will be done manually. When it has done manually, there is continuous supply. Can you expect or not? No, no. There is a discontinuous supply. Any failure happen, there is discontinuous supply will happen. Now the failures, blockouts will happen, unlimited control choice for few customers. Try to understand. Previously we are having electromechanical systems were exist, and it was a one-way communication, power generated at central level only, one place only. Since we are transmitting one place to long distances, losses are very high. Losses are very high. So very few sensors are used. Problem identification also, manual monitoring is required. Restoration also, it is manual. So that's the reason because of which it is failures you will observe, blockouts were there, unlimited control, choice for very few customers. Now, if you consider future grid, how the smart grid will be? It will be digital in nature. It will be digital since you are using a smart meters throughout the network and gas insulated substations you are considering. Okay, advanced infrastructure you are taking. So smart grid will be 21st century grid will be digital in nature and it will become two-way communication. Why two-way communication? Since you are deploying your smart meters, you can implement the relay circuit operation from your desk, automated. From your desk, you can operate control algorithm can be provided in such a way that that instant itself you can isolate the section or you can connect the section. Am I getting or not? So through the smart meters, you are getting, it is a two-way communication, not only acquiring the data, even any command if you want to give, it can be given also. It is a two-way communication. And second thing, the power is not centralized, it is distributed throughout the network. How? As I said, so we are having solar parks are there, even in the national highways we are having windmills are available. At your home there are rooftop PV systems are there. Am I getting or not? So earlier it was centralized power. Now power is distributed. Since it is distributed, definitely losses are reduced. You are not dragging the power from long distance. Okay. So throughout the network sensors we are using, self-monitoring, self-healing is possible, and adaptive control and islanding condition also it will work. What is meant by islanding condition? So even though our house is not connected with the grid, you are having rooftop PV system is there. So then what happened with the help of rooftop energy, how much your power is acquired from solar, which can be stored in the batteries, which can be utilized when there is no power supply. Am I getting? So even islanding condition, standalone condition, even though when it is not connected with the grid also, since you are having distributed generations, microgrid operation you are having and small amount of networks at your home level, at your residential or commercial industrial level you are having, rooftop PV systems are existing. So with that islanding is possible. Islanding in the sense you can operate your systems without connecting with the grid also for particular amount of time. Fine. Based on the capacity, how much your microgrid has. It is pervasive control, full control will be there and choice for many customers. Is it okay? Do you understand? So smart grid will be digital in nature, and in the smart grid we are employing the smart meters. We are considering information communication protocols and merging the energy network with the communication network. Then grid intelligence people are using, SCADA systems people are using. SCADA means you know, no? What is SCADA? Supervisory controlling and data acquisition. What does it mean? We are acquiring the data from each and every field terminal points and you are doing the controlling over it. Okay, after acquiring the data, you are acting accordingly if there is any fault is there. That's called SCADA system, supervisory controlling and data acquisition. Fine. Now we will go further. See, we will try to see how the past grid was, how the future grid is, how the present grid, how the future grid. Then I will go in detail with EVs. Fine. So how the past grid was, as I said, so generation, here two things are there. One is the dotted lines are information flow and this is power flow. Fine. So how the generation was? Generation was with conventional, generation was with the thermal, then which is transmitted, then which is distributed. Here we are having residential, commercial, industrial loads are there. Clear? If you want information through the telephonic operation, people used to collect the data. Fine. Now, here the advantage and disadvantage. The disadvantage is mainly it is since it is a coal you are using, thermal and hydro you are using. So these are non-renewable systems. Once after certain use, then what will happen? What will happen? It will exhaust. Then after that, what is required? It will be difficult to again replenish. So that's the reason. So here and even losses are very high. Since it is a central, it need to be transmitted, it need to be distributed longer distances. So the losses are very high. And information, if you want, here the telephonic operation, people used to collect the data from generation, from the transmission, from the distribution. People used to collect the data from each and every feeds. That is one way communication. Is it clear? Now, so here if you see, the past was we are having thermal and hydel is there. People used to collect the data through telephonic operation. Okay. Now if you see the present grid, in the present grid what we are having, along with the non-conventional, along with the thermal and hydel, what we have? We have the renewable energy sources are there. The people are generating power. What is the renewable energy? So we are having wind, solar is there at utility level. We are having wind and solar is there at utility level. Okay. So now this amount of energy will be transmitted and will be distributed. At utility level, we are having both conventional and non-conventional energy is there. Clear? Not only that, if you observe at distribution, now at present, most of the houses are equipped with rooftop PV systems. Isn't it or not? Fine. So it is little bit distributed in nature also. Even if you see, I told you, wind is throughout the network along the path. It is national highways. It is already installed. Am I clear? So what happened? So at present we are having both conventional energy is there, both non-conventional. Non-conventional in the sense renewable also we are having at generation level. Even at distribution also we have started generating the power with the help of rooftop PV systems. Clear? So small amount of energy can be acquired from PV form. Is it okay? Now information how people used to collect. Information they are using SCADA system like through not the telephonic operation. The people can understand. They will have a relay circuits will be there, SCADA systems. They will get the data in the screens. You might have observed, no? You might have gone to some substations. Okay. So now people are collecting the data through the SCADA system. Fine. Now, what will be the future from present to 21st century smart grid? I told you, no. In the 21st century smart grid, how it is going to change? Same, along with conventional, we are going to have already we are having renewable is there. Rooftop, if you see here, distribution, if you see, PV is there. Even EV is also coming now. EV charging infrastructures are coming at house level. That is called futures. That is called smart grid. Okay. Now, throughout the network, you are going to have PV integrated EV charging station. What is PV integrated EV charging station? We are having your slide was there, no? Have you observed the background? What it is? A charging station with. Okay. Let me show you that first. Then I'll come back. Suppose if you have charging infrastructure like this, what will happen? If you have a charging infrastructure like this, so you need to depend upon which one? Grid energy. Demand response will increase. Demand response will increase. There is what will happen? You need to maintain what? Load balancing has to be maintained, isn't it? Reactive power compensation issues will come. Demand response has to be maintained. So, but if suppose if you go with this structure, your backdrop is that one only, no? PV integrated EV charging structure or EV charging infrastructure. So if I go with PV integrated EV charging infrastructure, what is the advantage? Can you tell me? You are extracting the energy, natural energy. Understood? So on top of one car, how many panels are there? Can you observe? Can you see clearly? Roughly. You try to visualize properly. This side is there, that side also there. How many are there roughly? Like 16 not. You visualize one PV panel of how much size will be there? Maybe this much. How can I say? 8, maybe 6 by 5 feet. Even 5, it's not 5 by 4 feet. 4 also not. 2.5 to 3 feet. 5 by 3 feet you say take. Suppose. So 1, 2, 3, 4, 5, 6, 7, 8 only. Half only will be there, not more than that. Suppose one PV panel, what is the rating? Can you say? How much amount of power is there? Installation capacity of one PV panel. Your final years know which year? Okay, one PV panel, how much ratings are there? You are having 200 watt, 300 watt, even 500 watt PV panels are there. Is there or not? So suppose if you have a 500 watt PV panel, okay, how many panels are installed on top of one vehicle? 8. One PV panel installation capacity is 500 watts if I consider. 8 panels are installed on top of, so how much? So 4 kilowatt. So installation capacity of a PV integrated EV charging station top of one vehicle is how much? One vehicle is 4 kilowatt. Suppose you try to consider like this 10 vehicles EV charging infrastructure is there. How much I can install? One vehicle on top of one vehicle roughly 4 kilowatt if I am installing. So on top of 10 vehicles place how much? 40 kilowatt I can install. Through this what I am doing here, I am fully dependent on the grid. Here what is happening? There is demand response is increasing on the grid, stability issues are coming on the grid. Now if I go through PV integrated EV charging stations, what is the advantage? We could able to generate excess amount of energy. Same space is required for 10 vehicle charging. But on top of that, if you go with this structure, what will happen? Even one charging station with 40 to 50 kilowatts you are going to install. Now you think every village has like this, maybe outskirts of the city you are having one PV integrated EV charging station is available. How much I can generate? Am I getting? If you go to national highways, you are having PV integrated EV charging station is there. How much can be installed? A huge amount of energy can be installed. Getting my point or not? Okay. So here what will happen? How much amount of power is required that can be utilized, or excess amount of energy can be connected to the grid. Even you can supply power to the grid. You can supply back to the grid. Online grid you can connect. Or else what can be done? Morning you are extracting more amount of energy. Since PV panels will not work in the evening or night, so what we can do? We can store the amount of energy in the form of batteries, then it can be utilized in the evening. It will be self-dependent. You are not depending on anyone. Am I getting or not? Do you understand this structure? So now, we assume these type of PV integrated EV charging stations throughout the transmission line you are having. That's what I want to tell you. In the future grid, you are going to have not only which one? Conventional and renewable energy at utility level, at distribution level also we are having, at home level also we are having rooftop PVs are there. We are having EV charging infrastructures will be there. Even at residential level, even industrial level, commercial levels, you can have PV integrated EV charging stations. You can have not only that, throughout the network transmission, throughout the transmission and distribution also. Throughout the transmission and distribution, you are going to have PV integrated EV charging stations. Then how much I can install? That's what in the form of microgrid. Every PV charging station, integrated charging station will form as one microgrid, small amount of grid. But all charging stations are called, it is a distributed nature. Getting or not? At one place, if I consider more amount of PV panels, bulk PV panels, lakhs of PV panels, if I generate, it is called bulk grid. And one PV integrated EV charging which is generating 1 megawatt, that is called microgrid. These 1 megawatts are connected throughout the line is distributed. Clear? So how much power I can generate? You can visualize. So that's why the target is the renewable power generation of 500 gigawatt by 2030 is feasible. Clear? Is it okay? Do you understand? 21st century smart grid is you are having throughout the structure PV integrated charging stations will be there. Not only that, have you observed this? Storage will play a vital role. Having PV integrated EV charging station is not a matter. You can have, but how to operate is what matters. Why? You will have it. Solar power is exists only in the morning sessions, only daytime, night time. So excess amount of energy should be stored in the storage. At night it can be utilized. Or if excess amount of power is not there, then what we can do? We can depend on the grid also. Online grid it can be connected. Fine. So this is what the structure. So even throughout the distributed network we will have. I have shown in the previous slide. I have shown only EV charging infrastructure, but actually throughout the network, you will be having what? Wind, solar parks will be there. Okay, windmills you might have observed. Windmills, solar parks, everything will be there throughout the network, and the data will be stored in the energy will be stored in the batteries. Data will be stored in the data centers cloud. Is it okay? Now, this is what the structure. As I said, what is meant by microgrid is a combination of n number of energy sources which can be connected. It can be at one small amount of place. Okay, what we are generating, we are having utility power is there, solar energy is available, we are having batteries are there, we are having wind power is there, DG will be there. All together, we is able to give it to one particular colony or one particular industry or one particular commercial loads or residential loads, maybe apartment system. So that is called a microgrid. That microgrid consists of, it can be integrated and it can be alone. You can have a solar, wind, EV charging infrastructures can be there, batteries, diesel generators, even grid connected all together. It's called a microgrid. Now, if you have a microgrid, what advantages will be there? What is the impact of DER, distributed energy resources, on the grid? Okay, so what impacts will be there? Suppose you are having distributed energy resources. That means you are having wind, PV integrated EV charging stations, solar parks throughout the network. What advantage is there? You no need to depend on the conventional grid, which earlier used to depend and used to drag the data, used to collect the data from long distances. No, losses were very high. But now, due to distributed energy resources, due to microgrids and distributed energy resources, what is happening? Grid reliability will be increasing. Why? Even though at generation level, utility level, you don't have any power, but you have what? Wind energy is there. PV integrated EV charging stations are there. There you can generate the power. Rooftop PVs at home you can generate the power. Am I getting? Am I clear? So grid reliability is increased. Why? You are having fixed PV systems, EV systems, wind energy systems are there. Reliability is increased. Even grid flexibility will be enhanced. When and how it is required, accordingly connection and disconnection can be done with the relay circuits. And voltage and frequency regulations are possible. Only one thing, integration challenges you need to take care. Okay, when to integrate, how to integrate, what elements has to be integrated. Okay, so grid planning and operation will be easier. Grid congestion will be reduced. Demand response will be maintained. Stability will be enhanced. Okay, that is the advantage. So why we are doing, what benefits are there? Improved energy resilience. That means we'll have a stability will be there. Okay, greenhouse emissions are reduced. How the greenhouse emissions are reduced? Wind energy. There are no, which one? Losses will be very less. Carbon emissions are not there. So clean air objective only you are achieving. So through wind, through solar, or through EV, PV integrated EV charging station, what we are going to get? There is greenhouse emissions are reduced. Am I clear? So one more thing, energy cost savings also will happen. Okay, and environmental benefits will be there. How the environmental benefits? Since if you go with thermal mode, pollution will be very high. If you go with nuclear, there is environmental impacts will be there. But if you go with wind, PV, EV charging stations, environmental benefits will be very high, and the flexibility, scalability will be very high, and grid support services Everything is happening. Fine. Now, essential elements of smart grid. What is that? We are having deep energy efficiency we can achieve. What is meant by deep energy efficiency can be enhanced? I told you already. 4 6 times I told you. Efficiency will be enhanced. How efficiency is enhanced? Since you are using, since losses are less. How the losses are less? Since you are using distributed generation. Since you are using microgrid forms. So losses are reduced, efficiency is enhanced. Fine. The previously what people used to consider, you have studied HVDC, fax devices you have studied, no? Flexible AC transmission. First chapter you might have studied, no? The power, no, long distance transmission if you do, DC stable power is there, but AC after certain amount of kilometers there is a power drop you might have seen. Why it will happen? Due to skin effect, due to proximity effect. There are other losses will be, since it is a frequency dependent component, there is the power drop you will observe after certain amount of kilometers, isn't it or not? Now what is required to enhance the power or to improve the power transfer capability? What is required? If there are any voltage imbalances are there are current imbalances are there, or harmonic issues are there. Voltage imbalance in the sense if there is a sag, swell, power interruptions, or there is current harmonics are there, or there are voltage harmonics are there, flickers, anything is there. What we need to use? You are having series compensation techniques are there, shunt devices are there, and UPQC is there. What is meant by that? D-STATCOM, DVR, UPQC is there. Distributed static compensator, dynamic voltage restorers, unified power quality conditioners are there. With the help of that, you can inject required amount of current, you can inject required amount of voltage. Am I clear? But that is required for what? Long distance if you transmit the power. But if you have a distributed power is available at each and every point, small distance itself, do we need excess amount of extra compensation techniques? Is it required? Am I clear? Fine. So the previously for high voltage AC transmission HVAC systems, we need to have what fax devices need to be introduced, and which will be again costly. It can be thyristor based or VSC based, it's your call. But here deep energy efficiency can be achieved by going with smart grid. That means by going with distributed energy resources, you can achieve energy efficiency. Second one, demand management is possible. The demand response we are achieving quickly. Grid intelligence is there. Since you are using the smart meters, it acts intelligently, isn't it or not? Intelligent means what? We can acquire that when to interrupt the system or when to isolate the system, when the circuit breaker has to be connected, when the understood, when it has to be isolated. Everything you should understand. Grid intelligence is possible. Clean power we are getting through which one? EVs and storage. The future what we are having is foundation level also we are looking. What is foundation level? Circuit topologies people are changing. How they are changing? Have you studied about restructured power system? So what they will do, gas insulated substations people are going to consider rather than normal. Gas insulated substations people will consider. Smart meters they are going to consider. So if you consider smart meters, if you employ all the smart meters in the circuit level. Second one, you are integrating communication network with the energy network. If you integrate the communication protocols in the energy network, one is employing the smart meter circuit level, gas insulated substations in the circuit level. Second one is employing communication protocols. The fundamental, these are the changes will be done. By adding communication protocols, by adding smart meters, what will happen? Substation automation will happen. Distribution automation can be done. Can be done or not? Okay. Then we are having EV connection. PV integrated EV chargers can be connected. Ultimately, we will get demand response in better way we can address. And efficiency will be enhanced. Clear? So we will go to EVs. Is it clear till this? Now, what is the benefits of going with EVs? Is electric vehicles can save more than 70% of fuel cost. Why? You are not depending upon the crude oils. You are depending upon what? If you have backdrop, what you have PV integrated EV charging stations, if you have, then saving of fuel is possible. Or else your electricity bill will be very high. Okay. So second one, we are having what we have driving electric vehicles. You will get a clean air objective. That means if you use normal vehicles, there is carbon emissions will be there. If you use EVs, the carbon emissions are very minimal, so you can achieve the clean air objective. There is no tailpipe emissions will be there. Clear? EVs will have less amount of carbon emissions will be there compared to normal IC engines, and you can support independently. You don't need to depend on the crude oil, and you can enjoy the ride. So we are having different type of EVs are there. What we are having battery enabled EVs are there, fuel cell EVs are there, plug-in electric vehicles are there, hybrid electric vehicles are there. Again, series parallel combinations and hybrid structures are there. I will show you one by one. Before going to that, what is EV I will tell you, then I will come back. Okay. So what is normal electric vehicle is, or it's called battery electric vehicle. The first one you can see, battery electric vehicle. It has only battery will be there, full EV. It is called full EV, called battery electric vehicles. So full EV consists of only what? Batteries will be there. It based on that one it will run. Okay. Now, what is meant by hybrid? Normal full EV is no IC engine. There is no IC engine. We are having only electric vehicle, electric drives are there. So its battery package is more than 20 kilowatt hours will be there. Is it clear? 20 to 80 kilowatt hours. Now, hybrid in the sense a combination of IC engine, and battery is called hybrid electric vehicle. Clear? A combination of hybrid electric vehicle means a combination of both batteries and IC engine is called hybrid. When you call it as a plug-in, when you have external charging is there, plug-in in the sense it is also hybrid system, which is a combination of both batteries and IC engines with plug-in capability. Hybrid in the sense it does not mean you are having plug-in. Try to understand. Full EV consists of only batteries. There is no IC engine. Is it clear? First one. Second one. When you consider hybrid electric vehicles, electric vehicle is a combination of both. But here, if you have batteries are small in range, IC engine is in a bigger size, batteries get charged through which one? IC engine. So that's what here you see. Batteries get charged by the IC engine. Am I clear? If batteries are getting charged through the IC engine in the sense, it is mild hybrid, battery size is less and IC engine size is more. There is no plug-in capability. Whereas plug-in hybrid electric vehicles, reverse. What it is? Your battery size is double the IC engine, so batteries get charged through the external source. Am I clear? Now do you understand difference? Full EV is you are having full battery electric vehicles are there. When you consider hybrid electric vehicles, you are having a combination of both. Which one? Both batteries are there as well as IC engines are there, but batteries get charged through which one? IC engines. When you consider plug-in hybrid electric vehicles, then what is there? We are having external source of batteries are there, so size of the batteries will be higher than that of which one? IC engines. Am I clear? Now you can see this. So now if you consider battery enabled electric vehicles, only you are having batteries, no IC engine. So now if you consider this structure, so what it is? Plug-in is available. Okay, here one is of parallel combination, one is of hybrid combination. Suppose you don't consider this plug-in. Now size of battery is lesser and IC engine is bigger, then that will be called as normal hybrid. Clear? Difference do you understand? So if I consider conventional or conventional vehicles, IC engines, what will happen? Normal cars we are having, it will be run by either fuel of diesel or petrol. So your energy source is what? Fuel only. So full consumption is fuel only. Emissions are carbon emissions are less. If I consider hybrid vehicle, what I said hybrid vehicle? Hybrid is a combination of both IC engine and batteries. But whereas IC engine size is more, batteries get driven by IC engine. So you are having energy source is only fuel. IC engine size is large. Battery consumption is low. So small amount of carbon emissions are reduced because of small amount of battery. Now if I consider plug-in, you are having both. IC engine is there, batteries are there, but IC engine is small, batteries are double the measure. You are having plug-in capacity. So since you are having batteries double the measure are there, so carbon emissions are still reduced. If you go with full EV, energy source is only batteries, full of EVs, carbon emission is further reduced. What I want to tell you is, when you use IC engine, we are having carbon emissions are less. Our carbon emissions we can reduce is very less. But hybrid if you take little bit further reduced, plug-in if you take further, and full EV if you take, so through which we can achieve clean air objective. Okay. So we are having different type of charging infrastructures are there. So what we are having charging infrastructure? We are having AC charging is there, DC fast charging is there. Okay. So if we consider level 1 you leave it. If we consider AC charging, there is a this one 240 volts up to 19.2 kilowatt 80 amperes is there, and there is a DC fast charging of two levels are there, 200 volts to 500 volts 80 amperes is there, 200 volts to 500 volts 100 kilowatt 200 amperes are there. Suppose if we charge our vehicles, either two-wheeler, three-wheeler, four-wheelers, with the help of these levels, okay, so what will happen? Charge per hour of time, suppose we are having 3.3 kilowatt to 19 kilowatt structure is there, okay. So if I take level to 240 volts, 19.2 kilowatt, if I take, we can travel up to 60 miles. 60 miles in the sense 60 into 1.6. How much it is? Conversion of miles to kilometer is, you need to multiply with 1.6. How much it is? If I charge my vehicle for 1 hour, if it is connected to 240 volts 19.2 kilowatt charging infrastructure, it can charge, you can travel up to how many kilometers? 60 into 1.6, approximately 95 or something, 96. Your vehicle capacity is one full charge, you are ensuring 500 kilometers I can travel. Your full vehicle, full EV I have taken, full EV charge capacity is 500 kilometers I can travel. If it is the case, how many hours I need to charge? How many hours I need to charge? Or if I connect it to level 2, 1 hour of charging, 96 kilometers I can travel, 95 kilometers. If I want to travel 500 kilometers, approximately 5 hours I need to charge. This is when it is connected to level 2 charging. Now you go with DC fast charging. If it is a DC fast charging, 200 to 500 volts 80 amperes is there. And 40 kilowatt system if I connect, 1 hour of charging, it will ensure you can travel up to 120 miles. 120 into 1.6, how much it is? 12 into 1.6, how much? Approximately 180, 190 something. Huh? How much? How much it is? One 192. Now, for 500 kilometers, how many hours I need to charge? 192 in the sense approximately 200 kilometers. 200 kilometers we assume. So, 2.5 hours I can ensure that my vehicle get charged. If I connect with level 2, 5 hours I need to charge. If I connect with DC fast charging of 40 kilowatt system, within 2.5 hours I am ensuring. Next, 200 to 500 volts, 200 amperes system is there, and 100 kilowatt system. 1 hour of charging, 300 miles. That means 300 into 1.6. How much? 460 or 480? 480, 490. So within 1 hour I can ensure that vehicle get charged. Am I clear? Now if I connect with level 2 charging, normal AC charging, 5 hours it is taking. If I connect with DC level 1 charging, 2.5 hours it is taking. If I connect with DC level 2 charging, 1 hour is enough. At home, if you have a 3.3 kilowatt or 6.6 kilowatt or 9.6 kilowatt you are having, hours will change. What will happen? There is a possibility of maybe rather than 5 hours, it can take overnight charging of 10 hours also. Am I clear or not? Try to understand. It's not the charging is longer period. Where you are charging your vehicle is a matters. AC outlet if you charge, then it can take more time. A DC outlet if you charge, it can be a lesser time. Am I clear? Is it okay? This do you understand charging infrastructure? So this is what the structures what we are having. So I have already showed you what it is. Earlier we were having charging infrastructure how it was. So we were having only what we are having. Normal charging infrastructure is there. Because of this type of thing, what is happened? There is more demand is increasing on the grid and stability issues are happening. So the future is going to be PV integrated EV charging stations through which what happens? I told you already. Can you tell me? So what happens? Now on top of one vehicle, if I assume one PV panel installation capacity of 500 watts, if I consider one PV panel of 500 watts, if I consider on top of one vehicle, how many panels I can install? So 8 panels, 8 into 500. 4 kilowatt I can install on top of one vehicle, as I said already. So on top of 10 vehicles, 40 kilowatt. If I take 20 vehicles, so accordingly based on how much geographical space you are having, based on that installation capacity of each PV integrated EV charging station will increase. Am I clear? Now further one, what is required? Is it clear? So this is throughout your transmission to till distribution level, even national highways. Mostly these things where it will happen is outside the villages will be there. Within the villages we will not consider. Why? This type of structure is anywhere is okay. Why you don't have PV panels? Everywhere it can be okay. Reason is, but here the drawback is more demand response is increasing on the grid, stability issues are coming. People are suggesting to go with the future is PV integrated EV charging station. With this, you can install larger amount of energy. PV panels can be installed throughout the network. Mostly it can be installed where outskirts of the city or national highways, state highways, where you have a geographical space is there. And one more thing, the PV panels mainly depends upon this amount of power extraction is depends upon the irradiance or shading conditions. If you construct your PV integrated charging station next to highest building, if I construct, you are having PV integrated charging station is there. How your normal this one is there, petrol bunk is there. In place of that, if I take my PV integrated charging station next to the bigger building, if I construct, what will happen? So there is a shading will be there. You can't extract the maximum power. If nearer to the trees, if I construct, shading will happen. So you need to consider your PV integrated EV charging station in such a way that where you will get uniform irradiance where is available, there only I can consider. Am I clear? To extract maximum power. So these are the things. When you are designing public charging stations, what is required is when you consider AC charging station, more amount of time is required. DC, lesser amount of charging time is required. Now, if I want to have 200 to 500 volts of DC charging stations, at you need transformers. You need 33 by 11 kV cabling. Suppose 200 to 500 volts of that much of DC power is required. Definitely you need a 33 by 11 kV cables are required to give that much amount of DC energy. Am I getting or not? And having 33 by 11 where within the city may not be feasible. Outside the city if I take When I go with outside the city with 33 by 11 transformer structure, will I go with only small capacity? No. Definitely I should have a bigger capacity. Am I clear? Getting or not? If I'm installing 33 by 11 kV substation, if I'm having transformers of bigger transformers I'm taking, I should have a bigger charging station is required of capacity of not 10. People go with 20. If I go with 20 vehicle charging station, how much I can install? Installation of PV charging is how much it will be? 20 panels, if 20 vehicles charging is required. So on each 4 kilowatt, so 80 kilowatt I can install, or roughly I can say, so 100 kilowatts I can generate with one charging station. And second thing is adequate space is required, parking is required, adaptation of international standards are required. Not only this, one more problem with public charging stations is one is transformers, 33 by 11 kV substation required, adequate space is required, okay, and it should be free from tall buildings, it should be free from trees, other things, shading should not happen. And one more thing is either it can be islanded condition you can work or grid integration should happen. Why? When you are extracting the natural energy, how much you can store? You are having battery capacity is there. Batteries will energy will store. Morning time you are extracting and storing it, and night time sometimes requirement is there. You can utilize it. But the thing is, if you don't have that many customers, it should be connected with the grid. If I want to connect with the online grid, what is required? Bidirectional charging infrastructure is required. What is meant by bidirectional charging infrastructure? What is meant? One time I can connect grid to vehicle, another time vehicle to grid also should be connected. So, which is a combination of both converter and inverter circuits. Am I clear? Getting or not? We should design the bidirectional charging infrastructure plays a vital role. So, when you want to go with a public charging infrastructure, okay, so how you design? Suppose if I go with a PV panel of 80 kilowatt system is there. Now, converter I want to design. The converter design how you will do? One DC-DC converter if I want to design, it depends upon what? Input voltage how much is there, input current how much is there, okay. So then the percentage of voltage ripple how much, percentage of current ripple is how much, isn't it? Now your 40 kilowatt is becoming into 80 kilowatt. Your inductor capacitor values, everything will change, no, accordingly. Your switching frequency will change. Am I getting or not? It does not mean just bring and connect it. The module integrated structures has to be considered. Now you are having multi-level inverter structures are there. A module multi-level converters are there. Am I clear? Have you studied about bidirectional converters? You have studied, no? Bidirectional high gain converters will be there. So how much you are extracting the power, 80 kilowatt is there, that will be enhanced to higher level and which will be dumped. Am I clear? Fine. So when you are designing public charging infrastructures, one is transformers, one is substations, civil and adequate space is required. Not only that, standards you need to maintain, along with what type of converter is required, what type of inverter structure is required, what type of batteries are required, everything matters a lot. Fine. So these are issues. Now, if you go with EV charging infrastructure, what type of locations we are having? We are having different type of EV charging locations are there. It can be home charging, it can be destination charging, it can be which one? Opportunity charging will be there. What is meant by home charging? When it comes to home charging, we can have residential or fleet. What is meant by fleet? So, when you consider residential charging, you are having one vehicle is the electric vehicle. AC level 2 charging is enough, 5 hours you will keep or night, full night you will keep, no matter at all. One EV charging, one you are having DC charging infrastructure is there. Or AC charging is enough. DC also not required. At your home charging, you are having residential, you can have only AC level 2 is enough. Why overnight charging you will keep and remove your vehicle. One vehicle is there. What is meant by fleet is, at your home, there is a joint family. Fleet in the sense, group of vehicles. You are having more number of vehicles are there. Then what is required? You need multiple ports are required. you need to have multiple charging ports are required, and you should have the capacity of that much is required. Either multiple charging ports with that much amount of capacity at home it is required, but that is it won't be feasible. Multiple charging port point is feasible only at where corridors, corridors in the sense public places. But here I should have what I should have at least DC level 1 if I have. So every 3 hours I can change my vehicle. DC level 1 if you have, at least every 3 hours I can ensure one vehicle, suppose 5 vehicles at your home is there. You can ensure that the 5 vehicles get charged at any one point of time. Continuously I can't charge my vehicles also. Am I clear or not? So when you have only one vehicle at home, residential charging in the sense AC level 2 is enough. When you have a multiple vehicles at home, AC level 2 is not sufficient. You should have at least DC level 1. Second one, what is meant by destination charging is you are going to workplaces. You are having destinations are there. Suppose if you go to workplace or college if you come, then what will happen? Morning 9 to 1, maybe 2 to 5 is there. If we have DC charging infrastructure of DC level 1 or AC level 2 also, what will happen? At least you will get a time of minimum of 3 to 4 hours are you getting or not? One slot. Suppose 100 vehicles are there in your organization. If I have a 20 vehicle charging infra is sufficient. Why? Can you tell me? Try to understand. If I have 100 vehicles in the institute, the infrastructure 100 vehicles not required. Only 10 to 20 vehicles is more than enough. Why? One time, if I consider charging infrastructure of 3 hours, if I take DC level 1 is there, suppose DC level 1, 3 hours it is charging. One slot, if I charge, what will happen? Suppose one time if I charge my vehicle completely, 500 kilometers I am traveling. During weekdays, how many kilometers I will travel? Hardly 50 kilometers or 100 kilometers. Try to understand. At your workplace, if you have a DC level charging, what will happen? 2.5 hours to 3 hours charging is required. Morning I will keep, by lunchtime I will remove 10 vehicles. Afternoon I will keep, before evening I will remove. So 10 vehicles, in a day 20 vehicles can get charged. Now these 20 vehicles, one time if you charge, how many kilometers it can travel? During weekdays, you can travel how many kilometers? 500 kilometers, let us consider. Am I getting? So weekdays you will not travel so much. 50 to 100 kilometers is sufficient every day. In a week, 500 kilometers is sufficient. Now, weekends if it comes. Weekends if it comes. Your office is not working. Saturday, Sundays. Definitely you go to some destination, some malls you will go. Malls if you go at least 2 or 3 hours you can keep your vehicle. The vehicle can get charged. If mall is having the charging infrastructure is there, so there also 3 hours you can charge. If you go to theater, 3 hours it can charge. If you go to restaurant, within 1 hour it can charge. So even if you go to workplace, your time is not getting wasted. At your house, is the time is getting wasted? No. At your house, you are sleeping, your vehicle is getting charged. At your workplace, you are going to your office work or academic works or administrative work, your vehicle is getting charged. Rather than keeping in normal charging, you are keeping in the PV integrated EV charging stations are there. Rather than keeping vehicle in the normal place, charging station you are keeping your vehicle. It is get charged. Are you wasting your time? No. If you go to destinations, shopping complex if you go, there also 2 to 3 hours your vehicle get charged. You are not waiting for that. Even what is opportunity charging? Corridors. When you are traveling long distance, suppose you take a situation, this is at home no issue, at workplace no issue, even at shopping complex no issue. When I travel, then more than 500 kilometers if I want to go. So from here to go 1000 kilometers is there. I need to charge twice. How it is possible you may ask me. At least I need to have food. So when I go to any charging station nearby, if you observe, mostly which one is there? Food courts are there. The food court, EV charging station, along with the food court is there. So we will wait for 1 hour for food. This 1 hour your vehicle also get charged. Am I clear? Even long distance when you want to travel also, on the national highways, on the state highways, the people are going to consider EV integrated EV charging stations. You can charge your vehicle without wasting your time. During that time, you can have your food. During this process, do you think if you charge your vehicle, your time is wasted? Definitely no. Fine. If you are telling that, then you don't understand fully what is aiming. If you see the structure, this is EV charging locations what we are having. If you observe clearly, home charging is a residential charging. One vehicle is here clearly we have given in our paper. So this is a residential charging, AC level 1 or 2 we can go. Home with fleet charging, more than one vehicle is there. More than home fleet charging, more than one vehicle is there. We will go with DC level 1. If you go with public charging, what is public charging? Corridors. Public charging in the sense you can have only grid connection AC level 2, DC level 1, DC level 2. Which one AC level 2 I will connect? We are having a scooty, two-wheeler. Two-wheeler having lesser capacity. It can be connected to AC level 2. Four-wheelers has to be connected to here. Four-wheelers also fully EV should be connected to DC level 1. If it is not fully EV, mild normal plug-in, which has a capacity is less. Either it can be connected to AC level 2 also. Am I clear? Then we are having PV integrated EV charging stations are there. PV, wind, battery integrated EV charging stations also will be available. On the corridors if you go, you will have only grid connection will be there. Yet, where? At cities, highways if you go, solar park with PV integrated systems are there. Even some national highways you will have PV, wind, battery integrated EV charging stations will be there. Clear? And third one is you will have destination at shopping malls, you will have destination at even academic organizations. This one you understand? Is it okay? Now, so this is what the structure. There are common myths are there. The people will say plug-in vehicles can only support short trips. Is it true? It can only support short trip? No, no. So based on your vehicle capacity, the size will change. So people will say plug-in vehicles are not clean. I have shown you one slide. IC engines, if I take, carbon emissions are very high. I can't reduce more. If I go with hybrid vehicles, carbon emissions are reduced. If I go with plug-in hybrid, carbon emissions are further reduced. If I go with full electric, the carbon emissions are further reduced. So it is the emissions will be there, but it is very less. The people say electric vehicles will make your energy bill high. Yes, it is true, but you have your slide is there, no? PV integrated EV charging stations. If you have, you are extracting natural energy, will it cost you anything? If you don't have a rooftop PV system with a charging station, yes, bill will be high. But if you have a PV integrated EV charging stations, when you extract the energy from natural sources, then the bill won't be high. If you are not extracting, if your charging station at home also you can have charging stations. If you have a PV integrated EV charging station at home, then it is bill is less. If you don't use that, then it will be high. And people will say there is electric vehicles are far more expensive than average car. Yes, it is true, but the government is giving incentive. Do you know for 1 kilowatt hour how much they are giving incentive? Based on battery package size. It's not based on two-wheeler, three-wheeler, four-wheeler. It's based on the battery capacity of the vehicle. The incentive will be there. How much it is? Can you tell me? How much it is? For 1 kilowatt hour, earlier they used to give 10,000 rupees. Now people are giving 15,000 rupees for 1 kilowatt hour. Generally, two-wheeler, what is the battery capacity? What is two-wheeler battery capacity? Finally, only. What is the battery capacity of two-wheeler? 3 to 4 kilowatt will be there, not more than that. If you have a 3 kilowatt battery is there for your vehicle, 3 to 4 kilowatt battery, so how much incentive you can get a maximum? 45,000 to 60,000. Am I clear? If you go with mild hybrid in the sense you are having IC engine is more, battery is small. Similar with two-wheeler, you will get money. If you have a plug-in electric vehicle which has battery size is higher, and the IC engine size is lower. So you have a capacity of 20 kilowatt hour is there. Then you may get accordingly. But if you have a full EV, you will get more incentive amount. Am I clear? So to support that, we are having a FAME India scheme is there. What is that FAME India scheme? Can you tell me? To support electric vehicles adaptation. What I told you, we have NEMP plan is there. Under NEMP plan, they have initialized FAME India scheme to develop which one? Or to support the development of electric vehicles. The government has initialized NEMP plan, National Electricity Mobility Mission Plan. Under NEMP, they have initialized which one? FAME scheme. Here you can see the government of India has initialized NEMP plan. The aim is to achieve fuel security by promoting EVs. Under that FAME India scheme has they have considered. Already you have read now what is FAME India scheme? Can you tell me now? Faster adaptation of the name itself, faster adaptation of manufacturing hybrid electric vehicles. They want to go for adoption and manufacturing of hybrid electric vehicles. FAME India scheme is that. Okay. So when it is initialized, the mission NEMP plan was 2020 was there. It was initialized in 2011, unveiled in 2013, started in 2015. Try to understand. NEMP plan, FAME India scheme was initialized in 2011, unveiled in 2013, then started in 2015. For a period of actually it has initially started with 2 years but extended to 4 years. 2015 to 19 there is a FAME 1 scheme is there. Now 19 onwards FAME 2 scheme is there. Fine. So when you consider FAME 1 scheme, so it is initialized in 2011 and unveiled in 2013, and why they are considering? To support, encourage reliable, affordable, efficient EVs. Why affordable? Since they are giving incentives, it is affordable. Why it is reliable? Rather than IC engines, definitely batteries, EVs are reliable and efficient EVs people are going. So how many models were there? There are first initially 2 years are there, 137 models are there. Initially period 2 years, then it is extended. Fine. So now, how much was an incentive money? Can you tell me? Guess. It is for a period of 2015 to 19 it was there. So how much amount was allotted for the scheme? Any guess? As an incentive money to support EVs, how much amount might be under the scheme might be allotted? Can you say? Huh? Huh? How much? 10 crores. Anything? You are following nicely. Good. You have seen, no? Yes. Good, good. That is good. 10,000 crores allotted, not 10. 10,000 crores are allotted to give the incentives for the people. But how much we have utilized? Can you say? Any guess? The amount of consideration was, there are 137 models are there, OEMs. 10,000 crores are allotted. How much is utilized? Can you tell me? Huh? Anything? At least you can guess, no? Sir is telling 1,000. You can guess. Okay. Only 359 crores utilized. Out of 10,000 crores, people have utilized 359 crores. 2.8 lakh vehicles only incentive was given. Remaining 9,641 crores, where it went? People knows other schemes gone. People are not utilizing. It is diverted to where it can be utilized. Fine. So only initially people have considered 359 crores only, 2.8 lakhs only. Why? What is the reason? Can you tell me? Why people unable to utilize that 10,000 crores? Reason is unawareness. People unaware of the schemes, the incentives available. Not only that, not only unavailability. Second thing is lack of charging infrastructure. Even if I want to buy, where I can charge my vehicle? Lack of charging infrastructure is first thing. Even though people hesitate to buy due to lack of charging infrastructure. Am I clear? Now, since as I said, the first I said we are going everything EV, PV, microgrid, everything for clean air objective we are going. So with this, how much we have achieved the clean air objective is, how much people have saved is with just 2.5 lakh. In a year, 50 million liters they have saved. That means dependency on the crude oil, foreign oil, 50 million liters you have not taken from them, no. That means fuel saving per day is 52,000 liters with 2.8 lakh vehicles. And how much carbon emissions is there per day? 1.3 lakh kgs. And total carbon emissions per year is 129 million kgs of carbon is reduced. If 129 million kgs of carbon reduced, linear objective will achieve or no? Through EVs, 129 kgs of carbon emission is reduced. That is the advantage. Fine, you understand? So, where is the highest, where is the lowest is? So, that is a period of 2015 to 2019 March financial years. 2015 April to 2019 March financial years. Okay. So, now, highest vehicle sold in where? Can you say? Highest vehicle sold? Maharashtra. It is of Maharashtra. Maharashtra is 36,597 and lowest is which includes two-wheelers, three-wheelers, four-wheelers, autos, buses, everything. Lowest is what? Meghalaya is 6 and Andhra how much it is? 10,265 vehicles during only period of 15 to 19 I want to tell you. So now what happened? So to support the EV adaptation, people have deployed sanctioned electric buses. You might have seen, no? Inter and intra-cities buses they have sanctioned, and again they have come up with phase 2. What is phase 2? Phase 2 again they have allotted 10,000 crores, and to support how many? 7,000 buses, 5 lakh three-wheelers, 55,000 four-wheelers they want to support. Okay, quickly I will go. So how much they have done as on date of 2024? 16 lakh vehicles. At least now can you tell me? First phase 2.8 lakh. Second phase, first phase 359 crores utilized. Second phase how much we have utilized? Have you seen? Now, how much? 16 lakh vehicles were sold. 16.71. How much amount do we have utilized? 2019 it has started. How much we have utilized? Can you say? Huh? So it should be increased, no? So 6,800 crores utilized. Second phase again 10,000 crores they have allotted. 6,000 crores, 6,800 crores utilized. Okay. Now you see, with effect from 11th June, EV increased from that incentive amount is increased to 15,000 per kilowatt hour from 10,000 per kilowatt hour. Okay, to further push EVs, they have taken expression of interest from the people. Okay, so then people have given there is which one? Buses they have deployed. EV buses you might have seen, no? EV buses to give the further push they have deployed the buses. AP we are having 300 buses they have deployed initial phase. So every place they have deployed more than 5,000 buses they have deployed. They have taken expression interest from where it is deployed. Where it is deployed. Where million plus people are there. Where which is a capital city, which is a capital city, which is a smart city, which is a special category city, or where million plus people are there, there only these buses are deployed. Am I clear? There are very few buses intercity operation also they have considered. Okay, so this is the structure. Fine. This is what required. So straight I will go to that structure. Then after that, to give the further push, what they have done, even they have sanctioned EV charging infrastructures. Charging infrastructures also they have given to million plus cities, capital cities, only special category cities only it has given. Fine. Even national highways, EV charging stations they have given, and highways they have given. Okay. So these are the structures. So year by year it is increased. These are all things not required. Now this one is required. So now when they want to implement EV charging infrastructure, what is required is initially charging infra required. Second one RFID circuits are required. Third one connectors are required. First one is basic charging infrastructure is required. Then second one is display RFID controls are, those are controllers are required, relay circuits are required. Third one is for electronic converters. What is that one? Bidirectional charging infrastructure is required. Three phase wise they are doing. First one is basic charging infra, RFID protocols. Third one is grid integration. Okay. So this is what these are all are discussed only. This is not required. So straight away I will go to this is already two-wheeler also you see year by year there is sales are increased, even three-wheelers, even four-wheelers also sales are increased year by year. No, they are not required. So I will go to EV charging infrastructure. So we are having EV charging infrastructure of vehicle to grid, vehicle to vehicle, vehicle to load, vehicle to home is there. So you want to give them break for 5 minutes, then I will start that. Fine, no? 5 minutes you go for a break. Now next lecture I am going to explain you how the vehicle to grid, vehicle to home, vehicle to load, vehicle to vehicle, purely technical session it will be. Like during that time, so how what type of charging infrastructure is required, what type of converter required. So we'll try to see that. Fine.
Dear participants, we will have a tea break of 5 minutes. We will assemble again.
Drop this.
So we'll start the session after the tea break. Sir, please.
See. Okay, fine. In this session, please. Okay, fine. This session we will try to see V2X topologies. Okay. What is V2X topologies is vehicle to the X can be vehicle to grid, vehicle to load, vehicle to vehicle you can connect, or vehicle to home it can be connected. So in this process it can be bidirectional or unidirectional. Fine. So how it will be? Let me show you. See, we are having again n number are there. So you can connect grid to vehicle. You can connect grid to vehicle. You can connect from the grid. You are taking the power to the charging station. You are charging your electric vehicle. That is called grid to vehicle. What is vehicle to grid? So you can connect one vehicle to where it will be there. Even vehicle to grid can be connected. Vehicle to load can be connected. Vehicle to building can be connected. Vehicle to home. Vehicle to vehicle. What does it mean? If you take power from the grid to vehicle, it is called charge flows from grid to vehicle is G to V. If I want to give supply from vehicle to grid, that means from charge is flowing from vehicle to grid is V to G. When it is possible, so when there is grid is highest amount of power is there, 1 to 1 is feasible, grid to vehicle is possible. That is when even 1 and 1 is possible. When I want to connect vehicle to grid, single vehicle to grid is not feasible. Why? It has very small amount of power is there. So what we will do, when I want to connect grid to vehicle, so let me show you, sorry, vehicle to grid. This is the structure of a grid can be connected to n number of vehicles it can be connected, or it can be connected to grid to vehicle is 1 to 1 is okay. But the moment vehicle to grid reverse, if I want to give more amount of power supply from vehicle to excess power is there in your vehicle, if I want to give back to grid, so that time many vehicles to grid has to be connected. Am I clear? Difference, do you understand? Okay, why? I'll show you. Even not this structure, you have to go with PV integrated EVs with batteries, it will be connected to a grid. Difference, you understand? So I will tell you. Suppose you take a COVID situation. Okay, you take one laptop. You have purchased one laptop. Okay. Every day if you are using, charging, discharging is happening. There is no problem to that battery. 1 year, don't use that laptop. What will happen? You have purchased brand new laptop and you are not using for a period of more than 5 months. What will happen? Battery will get deteriorated or it may not work. Isn't it or not? To take a COVID situation, during the COVID situation, there is no movement of vehicles. If vehicle movement is not there, full electric vehicles are there. Then what will happen to the batteries of EVs? Am I clear? 3 years, you don't have it. Suppose if situation comes now, let us consider. Then what will happen? The batteries will be deteriorated, no? Then how to solve that situation? So in that situation, what we will do, or even sometimes more number of vehicles can be connected to the grid, it can give back power also. How it is? If more number of vehicles are connected together, you will take the vehicles will be connected to an aggregator. Through the aggregator, then you are giving DC-DC converter you are connecting and inverter you are connecting, then you are connecting to the grid. Many to one is possible. That means vehicle to grid you are connecting, it is many to one, not one to one. Clear? Am I clear? So, and this way small amount of power only you are giving. So more high gain converters here you have to use. But here you are having, future is going to be PV integrated EV charging stations people are calling. You are having PV integrated EV charging station is there. More number of vehicles are there. And you are having battery is there. You take a situation this way. So one company has procured vehicles, maybe Ola you take. They have procured 100 vehicles through loan. Morning time that 100 vehicles are going for traveling. He is having thousands of vehicles are there. Few vehicles are used for morning, few vehicles are used for night time. All the understood? No. If it is throughout the day, if it is going okay. Otherwise, some vehicles you are using for morning purpose, some vehicles you are using for night purpose. What we will do, when there is some vehicles, you are owning a vehicle, some 5 vehicles are there, or maybe 10 vehicles with you. Okay. You need to take a rest in the night time. During the time, what we will do, morning time it will do the service of society, it will take the people. Night time, what you will do, you will keep your vehicles in a particular place, all the vehicles together. Then that vehicles will be, power will be aggregated together, will be connected to converter, it will be, power will be enhanced, and it will be connected to the grid. That means morning it will be provide the service to the people, night time it will provide the service to the grid. Even if COVID situation comes, throughout the day you can connect your vehicles, charging and discharging can be done as per the requirement when you have excess amount of power is there in the batteries. Am I clear or not? Is it clear? So there is a vehicle to grid is possible, grid to vehicle also possible, but this feasibility will be enabled mainly when you have a PV integrated EV charging station only, excess power is there, then only we will connect. Otherwise, more number of EVs need to be connected together. If you have a PV integrated EV charging station, excess amount of power is through batteries also stored, which also can be given. So, when you consider the first one, we are having grid to vehicle is there. Grid to vehicle is 1 to 1. Grid to vehicle is, even one vehicle is there, I can take the power from the grid. Even 10 vehicles are there, I can take power from the grid. 1 to 1, 1 to many possible, grid to vehicle. Even vehicle to grid also possible now. So, when I consider this structure, now vehicle to grid is bidirectional, isn't it or not? Vehicle to grid is possible, grid to vehicle also possible. This is a bidirectional. That's why you need bidirectional charges are required. Converters when you use, not unidirectional converters, bidirectional converters has to be used. Am I clear? When I want to integrate EV with the grid, it should not be unidirectional. It should be bidirectional. Charging station has to be considered, particularly when you connect your vehicle with the grid. Now, vehicle to vehicle. That is both the ways bidirectional only. This vehicle to X vehicle to Y vehicle to X vehicle can be connected through the power line carrier only. Just when there is emergency power is required, it can be connected or not. Now, vehicle to home you take. Vehicle to home, mostly one vehicle is there at home. Home to vehicle is possible. You have a fleet of vehicles are there. Fleet in the sense group of vehicles. Fleet means group of vehicles are there. Same situation, you are going somewhere out of town you are going, or you are not using for a period of some particular period. What can be done? So you can do vehicle to home also can be connected when required, or vehicle to grid also can be connected through your house. Am I clear? Am I getting or not? Sometimes supply power is not there. Suddenly interruption is happened from the grid line. Interruption is happened. You are having 5 vehicles at home. Suddenly power is required. From the batteries can I take or not? So your vehicle to home is bidirectional. Home to vehicle is possible. Vehicle to home is possible when you have a fleet vehicle. When you have a more number of vehicles. Same. Vehicle to grid also fleet only. Bidirectional. This is bidirectional. This is bidirectional. Vehicle to vehicle also bidirectional. What about vehicle to load is? Vehicle to load is unidirectional. Why? You can't reverse it. Vehicle to load is unidirectional. Vehicle to grid is bidirectional. Both the ways can be connected with a fleet. Vehicle to home also bidirectional is possible with a fleet connection. Vehicle to vehicle also bidirectional. Is it clear? So these three cases you need bidirectional converters. These two cases especially bidirectional converters, vehicle to grid and vehicle to home, you need bidirectional charging infrastructures. Vehicle to vehicle is power line carrier only. Fine. Now even vehicle to building also people are enabling. What is vehicle to building? Building charging infra. Home is peak number of less number of vehicles, 5 vehicles are there. In a building, 20, 30 based on the building capacity. So if you take here, this is also PV integrated EV charging station. Make sure that, remember, it is a PV integrated EV charging station. Vehicle to building is possible. Building to vehicle also possible. V2G, V2B, V2B also there. Is it okay? Now we will go individually. When I consider power flow from grid to vehicle, when I want grid to vehicle, so first we are having AC power is available in the grid. AC to DC we are doing. DC to DC, how much is required? Less amount of power is required here. So DC to DC we are doing, and we are charging our all vehicles. So in this condition, what is required is you need to have bidirectional charging infrastructures are required in this structure. Especially bidirectional charging infrastructure is required. So bidirectional charging infrastructure is required in this way. Why? Many vehicles are there, whereas only one vehicle is there. At home you are having one vehicle is there. Can you able to give power to that grid? No. If it is the case, only unidirectional converter is enough. You are having different type of converters will be there. Bidirectional, unidirectional converters will be there. When I want to go for bidirectional converters, when I have fleet vehicles are there, then only I will go for bidirectional converters, bidirectional charging infrastructure. Unidirectional will be only when you have single vehicles are there. Clear? Now, so this is what vehicle to grid. Here also vehicle to grid also bidirectional charging infrastructure is required. Even this is PV and battery integrated EV charging station. Here also bidirectional is required. Why? One time we are taking power from either from the grid we are taking, or we are taking from PV panels we are taking. One time we are taking from batteries. One time EVs will take power from grid. One time EVs will take power from PV panels. One time PVs can take power from energy storage devices. But all three together will give power to grid. RS, PV and batteries together can be given to the grid also. Even no need of EVs. If excess power is there, you are having 1 megawatt system is there. If you don't have any EVs at your particular station, what you will do? How much amount of power is generated, that will be connected, diverted? No. You don't have EVs at your station. Somewhere you located national highways. No one is coming. Then what you can do? If people comes, you will utilize. If won't come, it will be diverted to grid. Am I clear? So going through the PV integrated EV charging station will not have any problem, even though people come for charging or not coming for charging. No issue at all. Either it can be work as islanded condition without connecting to the grid, or it can be connected to the grid connection also possible. Both the ways it can be worked. Am I clear? Is it okay? Now, so when we connect vehicle to the grid, what advantages will happen? To think that now you are having this structure, PV and battery enabled EV charging station is there. This one we are going to connect to the grid. With that, what advantages will be there? What is the advantage? When I connect that vehicle to grid, what will happen? Whenever it can reduce the peak power demand, isn't it? When you have a high peak power demand is there, peak power demand is there in the evening time. Okay, suppose you are having excess power of already which is stored in the batteries is there. You are having excess amount of EV batteries are there. Can I able to reduce the peak power demand or not? Am I clear or not? So when you connect more number of vehicle to the grid, when I connect this way, when I connect more number of vehicle to the grid, then what will happen? So we can reduce, first one is peak power demand can be reduced. Is it okay? Not only that, we can decrease investment on new power plants. You no need to go on investment on new power plants since you are having PV integrated EV charging station throughout the network you are having. throughout the line you are having. Suddenly that village, little bit of few houses added. In that particular village or in that city, few houses are added. Few loading capacity is increased. At the same time, you are having PV integrated EV charging infrastructure also added. No, that loading can be taken care by this PV integrated EV charging station. Am I clear? Is it okay? So you can participate in the wholesale markets. No need to investment on new power plants. From long distance, you need to track the power, and you can generate the revenues. You are reducing the peak power demand. No need to investment on new power plants. Since you are connecting with the grid, you are going to generate the revenues. Fine. Now, when you connected with PV integrated EV charging and batteries, grid stability increased. Why? You are not tracking the power from somewhere long distance. Losses are less here, and you know that how much power is available. System is stable only, reliable only, and secured power. Is it clear? Stability, reliability, security will be increased. And renewable energy storage, based on renewable energy storage which you are using, so it provides the grid services also, highly independent. Now, next one, when you consider load, how it is? You are having different type of loads are there, either it can be AC load or DC load. Okay, so electric vehicles will have what type of power we are having? DC. If your load is of DC load is there, I can't connect directly. Why? Your DC load may have particular voltage and current levels. Your vehicle has different voltage levels. I can't connect directly vehicle with a DC load. What I need is, in the middle, a converter is required. As per the requirement of the loading condition, either stepping up or stepping down has to be done. Am I clear? We can use a buck boost converter in such a way that whenever based on the loading conditions, it can be given. Clear? Vehicles will not be directly connected to the DC load conditions. What it will do, through a converter it has to be connected. If we have a AC load is there, yours is DC is available, it can't directly connect to AC load. How it should be connected? Through a converter, through inverter it will be connected. Clear? So, when I consider vehicle to load, where the vehicle to load has to be connected? Can you tell me? Where it is required? Where there is emergency power is required. Generally, your vehicle is there. If you want to consider as a load, where you need a emergency power, or where it should act as a generator, where the outage is there. Okay, so there only are some remote places you have gone. Outing you have went for a remote place where there is no power at all. You have taken your vehicle. So there also light load you can take no from your battery. Am I clear or not? If you go for long drive, somewhere long distance, where there is no electric supply at all. So there also, when there is, it provides a power, then there is a remote sites. It acts as a generator, it acts as an emergency power, it is highly independent and self-consumption. Vehicle to load, it can be connected. Okay. Even vehicle to home, either you connect with two ways it can be connected. Grid integrated, it can be connected, or PV, EV integrated houses also can be connected. So vehicle to home, if I connect, how it will be? Vehicle in the sense, more number of vehicles are there, it is connecting with the home. Then what will happen? Rooftop PV with EVs are there, so it will be highly independent. It acts as a generator when there is outage. Okay, it integrating with the renewable energies and self-consumption. You are reduced peak power demand and decrease in the new power plants. Am I clear? At your home, you are having rooftop PV system is there. At home, you are having EV charging infrastructure is there. If excess power is there, from the PVs, from the EVs, you can give back to your home. Your home, you are unable, you no need to take extra power from the grid. Your electricity bill consumption will be reduced. Is it clear? So now this is EV to EV, vehicle to vehicle if I want to connect. So it can be connected. So when it will work, yellow you can see, efficient EV park management possible, and self-consumption, it helps the other EVs. Okay. So these were the advantages of when we consider. There are certain advantages are there which we discussed. Vehicle to grid, vehicle to home, grid to vehicle. These are the things we discussed. Now, it can be unidirectional or bidirectional. I said no. Vehicle to grid if I connect, or grid to vehicle if I connect. Bidirectional or unidirectional. What are the services we are having is spinning reserve. That means load balancing. Grid regulation is possible. Peak shaving also like load leveling only. Okay. Then reactive power compensation and renewable energy supports. What we want is demand response. I want to maintain indirectly. Unidirection you consider or bidirection you consider. What we are doing is grid response we are maintaining. Peak level balancing we are doing. Reactive power compensation we are doing. Am I clear? So when you do that one, when you connect vehicle to the grid, what advantage we are having? Demand response means what? Vehicle to grid when I connect, load optimization we are doing or not? Vehicle to grid you have connected. So you are reducing the load, that means load optimization you are doing. When you do the load optimization, what type of energy you are injecting? Clean energy you are injecting. PV also clean energy. So carbon emissions are reduced. Load optimization is possible. At the same time, not only load optimization, carbon emissions are minimized. Negative. One is demand response you are maintaining. That means you are load optimization you are doing. Carbon emissions are minimized. Why carbon emissions are minimized? Otherwise, you need to take load from where? From long distance I have to take. Here when you connect distributed energy, the carbon emission is minimized. Second one is, since it is carbon emissions are minimized, then what will happen? There is cost will be minimized and you are having revenue will be maximized. Why revenue is maximized? Long distance if I want to collect the power, that much amount of cabling is also required. One is load optimization. Second one is carbon emissions are minimized. Clean air objective we are achieving. Second one is cost is minimized. How the cost is minimized? If I go with new power plants, so much amount is generation is required, long distance transmission is required, so cost is minimized, losses are minimized, and efficiency is enhanced, reliability is enhanced. Am I clear? When you connect with vehicle to grid, that means PV integrated battery enabled EV vehicle charging station is there. That one, if you want to connect with the grid, what happened? Load is minimized, carbon emissions are minimized, and revenue is maximized. Loss is also minimized. If losses is minimized, efficiency is enhanced. If efficiency is enhanced, reliability also is increasing. But what is the constraint? What is the constraint? Constraint is availability of EVs, charging and discharging rates. Have you heard about state of charge, state of health? What is state of charge? SOC? What is SOC? Secondly, what is SOC? You only. What is SOC? State of? What is it is? I told you already state of charge it is. What it is? How much amount of charge is available with the battery? State of health means the rate of charging and discharging, how it is happening. What is the thermal capacity? How the electrical capacity of battery is there? How humans having state of health of the person, state of the health of the battery is charging rates, how the discharging rates are there, how the heating capacities are there, electrical and thermal capacities, how the battery possesses. Then the rate and EV owner capacity. So based on this it will be done. So when you consider these systems, we are having as a whole, we are having renewable power is there, non-renewable is there, utility level. In the grid level, what we are having distributed generation is there, isn't it? So here what we are considering, PV integrated EV charging stations we are taking, V2G we are taking. This is called a smart grid. Smart grid in the sense, PV, wind, EVs, batteries integrating with the grid, either in the form of microgrid or in the form of bulk grid, or in the form of maybe distributed generation. If you connect, it is called smart grid. What is meant by smart home? PV integrated EV charging station with batteries, if I consider, and if you enable it, so that's called a smart home application. What is smart building application? PV integrated EV charging infrastructure with buildings. If you adopt, it is called smart building. Why you are calling it smart? The reason is you are going with the green energy along with when to operate relay circuits you will use. Automatically it will operate when there is a charging of how much is there. If connectivity disconnectivity happen, quickly relay circuits will operate either going to PV charging or PV discharging modes. Automatically it will be enabled. Here also PV integrated EV charging stations are there. We will consider a system in such a way that smart meter, smart relay circuits will be used. Either connect to disconnection will happen. So you are having smart grid application, smart home application, smart building application. Now to take a smart grid application, how many PVs you are taking? Large amount you are taking. The converter size also. For high voltage applications, you need to design a converter. Building you take. Building is medium voltage applications will be there. If you take home, how you are doing projects, BTech. So how you will do? You can take initially smart home application in the sense the power rating of small amount of power rating of PV integrated EV charging station I can design. When I design a bidirectional converter, so for low power ratings, if I want to design my converter inverter, it is smart home application. So converter will be with low voltage level I can design. If I want to design n number of vehicles connected either series in parallel or PV systems are connected in series or parallel, what I will consider? Medium voltage, at least compared to this, it is a medium voltage application I am going. So I need to design my converter to give medium voltage application, it has to work. So converter size and ratings will be increased here. If I go here, the converter design, how it will be decided? I told you already how it will be decided. Converter, if I want to design one converter, on what basis we will design? Based on input voltage, how much is there, input current, how much is there. If here PV integrated charging station is input is high voltage, currents also there, then what will happen? I need to design a converter for high voltage application. Clear? So for low voltage, medium voltage, high voltage application, we can design our charge controllers. That's what I can say, which is called smart home, smart grid, and smart building application. Now one more thing is there. Have you heard about smart road? Smart building in the sense PV integrated, EV enabled buildings. Smart home, one home. Grid is renewable integrated EV charging stations. Now what is smart road? What is smart road? Hmm? Hmm? Tell me. Installing? I am talking about generation. You are talking about consumption. I am talking about generation, installation. Heat lamp is what? It is a consumption. I am talking about consumer who is generating the power. Smart road. Smart roads, can you tell me? Have you heard about wireless power transfer, WPT? What is that? In Lucknow, 1 crore rupees I think they have allotted for smart road application. What it is, there are 3 lines will be there, highways if you go, this side 3 lines, that side 3 lines will be there. One line dedicatedly they are planning to have smart road wireless power transfer application in such a way that in vehicle goes, travels on that road by connecting charging mode. Automatically that wireless power transfer it will happen, vehicle automatically gets charged. Magnetic coupling effect will be there. On the road, vehicle travels, one line will be dedicated for which one? Smart road application. EV charging will happen automatically through wireless power transfer, WPT. Am I clear? You are having inductive, capacitive based, even hybrid structure of you are having that wireless power transfer topologies are there. Studied or not, I don't know. So future is going to be smart grid application and smart road application people are going to consider. There again, on the smart road, what they will consider, not only power of just generating some inductors, capacitor coils down to the earth. What they are going to consider? There are solar parks people will consider. People will consider next to that solar parks will be considered more amount of power will be given to solar parks or wind turbines will be there. It will give power to the particular things. Is it okay? Do you understand? So smart road application is mainly deals with wireless power transfer. So you are charging your vehicle that indirectly you are generating the power only. No, how much you can give the wireless power transfer based on how much you are having solar power. Is it okay? This is what. If you see the structure, this will be like this. Already I have shown you. So the parking lot vehicles will be there and it will be connected to the converters. And if you consider one more thing, all the smart road, smart grid, smart building application, everything is very crucial. What is required is batteries, BMS, battery management system. What type of batteries you are considering? How many types of batteries we are having? How many types of batteries we are having? We have electrical, we have mechanical batteries are there, we have chemical batteries are there, electrochemical, electromechanical, thermal. There are different types of batteries are there. Which battery way to use? That we should know. Understood? Why? The reason is, if you see now, you might have heard some EVs, two wheelers, no, or four wheelers. Suddenly there is a blast happen. Why? Due to thermal cooling issues. So heat sinks has to be provided. So we need to see a material in such a way that how the charging and discharging rate should happen, how the thermal coolant should be provided, how the heat sink should be there, and if I consider any battery management system, what is the longevity? That means longer period, how many years it can withstand and how many years it can work properly. Am I clear? So we are having different type of batteries are there in electrical. If you take supercapacitors, SMEs, different things are available. Fine. Then how the power management is? I have shown you batteries are there. Now batteries are connected to converters. Batteries will be inside the onboard charging. No, batteries will be connected to converter. The converters will be connected to inverter circuits. Then it will be connected to motor transmission pattern. This is full EV. Full EV means full batteries are there. Onboard charging it is called. Onboard is different. Offboard is different. Okay. Onboard is it is integrated within that. So here the batteries will be connected with the converters. Converters will be connected with the inverter structures. They will be connected with the motor structures and transmission is happening. This is what fully. What we are having? We are having hybrid structure also. EVs are there. When I consider hybrid structures, what it is? When I consider hybrid structure is a combination of IC engine and batteries. The batteries get driven by IC engines. That is hybrid. What is plug-in? Plug-in is separate charging infrastructure is there. Now, if it is plug-in, if I consider series parallel, fuel tank, IC engine, generator, converter, and there is inverter, it will be connected. This is one way. Second is plug-in if you have a batteries. After certain amount of time, then it can be converted to electric mode. IC engine mode or EV mode. EV mode is it can be connected like this. So it can shuffle in between, both also can happen. Even it is plug-in. If not plug-in, it can be connected to here. This is plug-in structure. Without plug-in structure, I want only hybrid structure. Then how the connection should be? I need to use one more isolated switch here. It should be connected here also. It should be connected to battery also. Batteries get charged through the IC. Am I clear? So we are having full EVs are there and we are having hybrid electric vehicles also there. So when the charging should happen. As I said, state of charge. First, what we will do, we will calculate power exchange levels, and your state of charge is less than 70%. Your battery itself less than 70%. What I need to do? I need to connect it to which one? Batteries is less than 70% is there. If it is yes, what I need to do? I need to connect it to grid to vehicle. Your vehicle get charged. Less than 70% is there. Then you should act as G2V mode. You are having charging a state of charge is above 70% is there. Then V2G will connect. Am I clear? You will see SOC calculation. Your vehicle is less than 70% is there. Then it will be G2V is enabled. The vehicle is above 70%, V2G can be enabled, but expected arrival time, expected departure time, how much time the vehicle will be there, based on that also it will be. It is not just your vehicle is having a charging of above 70. How much time you are going to be there? Just 5 minutes I will give charging and go. No. There is certain protocols will be there, certain timings will be there, then it has to be given. Here. So the mainly this one it depends. So this is already I have shown you what it is. If you have a grid connection line, already grid connected is there, 230 volts 58 system, then AC to DC conversion, grid to AC to DC conversion we are doing, the batteries, energy management system is happening like this. Gas insulated substations also with, this is called one of the hybrid systems. Either charging can happen, even to gas insulated also hybrid systems can happen. Main is this. So and again we are having V2V, V2G, V2H, V2B is there. Here you will have onboard chargers are there, off-board charging infrastructures are there. If you want in detail, you can study that onboard, off-board charging infrastructures. And not only that, the future people are going to work on wireless power transfer, how it will happen. Like now GPS is there, no? So tomorrow, if I want to say, suppose my vehicle is there, I want to enable charging, not taking the charge. As a prosumer, I want to convert. Suppose I am having excess power is there. I want to give it to the other vehicle. So even we can see, so which vehicle is having excess power, vehicle to vehicle you can integrate. Understood, no? Vehicle to peers, persons, vehicle to persons, vehicle to vehicle you can connect, vehicle to network you can connect. Through the network, vehicle to vehicle it will be connected, vehicle to the people also can be connected. So everything through the cloud it can be connected. So in this condition, I should understand what should be the standards, what type of communication networks I need to consider, what type of protocols need to be taken. So everything will play a vital role. Now you are having charging infrastructure. If I want to give one more vehicle, you should have a SOC proper. State of health of your battery should be proper. Then only I can give it to other vehicle. No. And so is your system is maintaining proper standards, proper protocols. If it is maintaining, then only other guy is ready to take you power from you. For that one, we are having IEEE IEC standards are there. For SOC, SOH, charging, discharging. That one I will show you. So when you are connecting, there are 4 disruptive technologies are there. One is how it will be connected, diverse mobility, autonomous driving, how it is, electrification. Electrification is PV integrated EV charging station we are taking. Here people have shown only EV charging. Now PV integrated EV charging station we are taking. So now how it is connected with the line, wireless communication. Okay, one vehicle to other vehicle connectivities, the driver's mobilities as well as autonomous driving. So when you go with a vehicle, now we are having a problem of charging infrastructure unavailability. It is not available fully. So at least when the person want to take a vehicle, hybrid mode, if you go hybrid vehicle, if you go no issue. If you go with full EV, the battery dries out, then what you will do? At least you should have a feasibility to get at least a little bit of charge through other vehicles. So these communication protocols will help you which EV is ready to give you excess power. Am I clear? Or nearby where I am having this, where I am having EV charging station. Nearby, how we will get the pop-ups when you are traveling through GPS. Nearby you are having this petrol bunk is nearby 1 kilometer or 2 kilometers. Nearby it will show you. No? So similarly, your vehicle will enable and it will show you how much distance you are having EV charging station, in how much distance one more vehicle is there who can give you power, or nearby building infrastructures where it is available. So everything it will be enabled through communication protocols. Okay, but only one thing. So we should understand standards and protocols should be maintained properly. Okay. So here there are certain drawbacks are there as of now. What is that? Market regulations are not proper. Rules and business processes must be clear. Why? Limited coordination between stakeholders are there. 137 models I have shown you, and even at present in the phase 2 model there are several are there. Okay, but the limited coordination between stakeholders are there, and battery degradation issues are there, and one more thing, non-uniform protocols are there. Lack of standardization is there. So because of which what happened, one vehicle with one standard, another vehicle with another standard is there. Then can I able to connect it? One is with the capacity of that vehicle is something, another vehicle capacity is something else. Can I able to connect? No, I need a clean converters are required. So non-uniform communication protocols, lack of standardization is there, we unawareness of VTX capacities are there. So there are certain disadvantages are there. That's the reason. So we could unable to go ahead with VTX topology. Is it clear? Do you understand? No. We will try to see what we discussed today. No. So let me show you quickly. Can you tell me? So what it is? Then I will explain you. There are solar parks available in India. I will try to explain you. Can you tell me what we discussed? At least did I reach it or not? I should understand. No. Once I understand you have understood something, then I will explain you the solar parks available in India. Other things I can tell you. First, I should understand how much is reached. Can you tell me what is the motivation behind? Motivation behind Indian structure. Can you tell me? Tell me what is required. One is clean transportation. Second one is charging infrastructure, and third one is 21st century smart grid is required. One is clean transportation. Clean transportation, how it is happen now? Through distributed grids, through microgrids. Clean transportation possible or not? What does it mean? Charging can be done with the help of DGs, using it. So now second one is charging infrastructure. So we have seen charging infrastructure also. We have seen 21st century grid also. Because of which what we are getting? We are getting carbon emissions are reduced, clean air objective we are getting. That's what. So first we have seen. Clear? Then after that what we have seen? How many are there? There are. Government of India has initiated how many schemes mainly? Mainly two schemes are there. First one is what? NEMP plan is National Electricity Mobility Mission Plan, that is 2020, through which what we are generating? So we are developing EVs, we are developing electric vehicles. So here target is 6 to 7 million vehicles. The second scheme is what? One is supporting EVs. Second one is what? Grid modernization. So grid modernization is happened with what? NSGM structures. Okay, National Smart Grid Mission. Okay, and one more thing, what we are doing is where people are encouraging to go ahead with only renewable energy. So renewable energy generation is by 2030 500 gigawatt is required. Fine. How it is? We are generating in the form of solar parks, in the form of EV integrated EV charging stations, in the form of windmills, in the form of what? We are having different renewable energy means what it consists of? Tidal is there, you know or not? What is that? Wind, solar, tidal, then geothermal also there. Okay. So we are going to, but mainly where we are going, what is the share of, do you know, in the renewable also, generation also. Now what is the share of solar, do you know? How much? What is the thermal percentage is there? I don't know. I'll show you. Okay. Renewable generation should be 500 gigawatt by 2030. Why we are doing it is, reason is to improve the air quality. Fine. Okay. So let us see. Then after that, new entrants are what I discussed. New entrants we have seen both PVs, EVs, smart meters we have seen. isn't it? Then after that, what we discussed, what is the vision of smart grid? Can you tell me now at least what is smart grid vision for India? Huh. What is that? Transforming Indian power sector into secure, adaptive, sustainable, digitally enabled ecosystem we want for reliable and quality energy, isn't it? So how we are achieving that? So can you tell me? So earlier we are having dump energy was there, so which is not connected to the communication protocol. Now what we are doing? We are combining, merging energy network with the communication network. So by merging energy network with the communication network, what is enabled? So smart meters we are installing everywhere. What is enabled? I will not show you that. I want answers from here. Please, I can understand like I have reached you something. What it is? Through the yes, real-time simulation is possible. Then wide area reliability is increased. Then network optimization is possible. Then participation of the customers is increased. Clear? So this is what. Then after that, what we are seeing, comparison between conventional grid and smart grid we have seen. So what conventional grid is having? It was electromechanical, then one-way communication, then tell me. Huh? Only very few sensors are there. Then if fault is occurred, manually need to monitor. Manual installation is required. So choice for very limited people, isn't it? And the power is central generation. Now can you tell me smart grid power? Digital, uh, two-way communication. Instead of central generation, it is distributed generation. More sensors, uh, automatic monitoring or self-monitoring, self-healing, and adaptive control island operation is possible. Fine. Now, in the past did how the structure was, generation was only through what? Conventional energy, that is the thermal and hydro is there. Then after that it is transmitted and distributed. Here, what is the drawback? Losses are very high. Power is not efficient and continued power supply you could not see. Okay. So how the information flow? Information flow was only one-way communication through telephonic operation. Now from past to when we have moved to present, what extra added in the generation? In the generation we have added renewables. What it is? PV and wind we have added. So again, it is in the generation. In the transmission, what we have added? Distributed generations are added. What it is? There are some solar parks are there now. There are, what is distributed power? There are windmills also added. At distribution level, rooftop PVs also we have. Rooftop PV systems are there or not at present? Understood? So how the information flow? Information is, earlier it was telephonic. Now SCADA systems people are considering. Is it clear? Is it okay? In the generation level changes, renewables we integrated. In the transmission, distributed generation we have included. In the distribution, rooftop PV systems we have enabled. Is it clear? Difference we understand. Now, when it comes to the information flow, SCADA systems are considered. Now, coming to present system, future what extra we have enabled? So in the generation extra, what we have integrated? Can you tell me? The generation. Wait. The reason of repetition is at least you go with some knowledge. Not necessarily talk. Can you tell me? Not that much software these people. So what we are considering? So when you consider the future systems, what it will be? Can you tell me? The future is what we are considering is that is a future is smart electric grid we are considering. In the smart electric grid, we will have the entire renewable energy sources we are considering. Throughout the network, what we are considering is Throughout the network, what we are considering is, can you tell me? There is PV integrated EV charging stations here. Am I clear? PV integrated EV charging station. Along with that, what extra we are considering? Smart meters you are integrating. Along with that, what we are adding? There is communication protocol we are integrating. Why it is called a smart grid? Reason is you are using a smart meters into the system. You are adding communication protocols into the system. You are adding PV integrated EV charging stations. You are adding into the system. Clear? And not only that, when you have a PV integrated EV charging stations, battery storage also matters a lot. Batteries you are considering, and cloud computing you are considering. That's called edge computing. So your data will be secured in the cloud and your energy is secured in the batteries. Both are different. Data will be secured in the cloud and energy is secured in the storage batteries. Clear? So throughout the structure, what changes are happening is PV integrated EV charging station and batteries and smart meters communication protocol. At distribution, what changes happen? Along with the PV integrated PV rooftop PV, we are considering what? PV integrated charging stations at home level we are considering, at residential, commercial, industrial also people are going to consider. Previously we have this, at present we are having rooftop PV systems. The future is going to be PV integrated EV charging stations, everyone is going to have. You understand? So this is what the structure. After that, what we discussed? We have discussed about impacts or microgrid. We have discussed the difference between bulk grid, microgrid, and distributed grid. I told you what is bulk grid. Large number of energy storage devices or farms are connected. It can be wind farm, it can be solar farm, or it can be integrated also. HRES it is called. Hybrid renewable energy sources also it is called. So if you generate huge amount of power at one particular place, it is called a bulk grid. Fine. What is distributed grid? You are generating the power through the power sources which are placed at distant places. Like it is connected, but it is connected not at one place, it is distributed. What is microgrid? Microgrid is a small form which can be used for a limited number of customers. So which includes PVs, wind, diesel generators and batteries. Is it okay? Next, what we discussed after that? We have discussed about impact of DER. So how it is? What impacts will be there? We need to look after how the grid reliability, how the grid flexible, is it flexible or not? When you are integrating DE, distributed energy resource into the system, definitely reliability, flexibility, even regulations, everything will be enhanced. But when to operate, you should understand. What to connect, you should understand. Okay. Otherwise, there will be issues will happen. Okay. So now, after that, benefits we have seen. What benefits we have? Stability, demand response, even carbon emissions are reduced, energy savings will happen. These things we have seen. After that, what we have seen? So we have seen about there is essential elements of smart grid we have seen. What essential elements we have? Efficiency is enhanced. Earlier we used to have patch devices for improving the efficiency, but now what we are using? Without that, we are getting efficiency. How it is efficient? Since you are using distributed sources, energy definitely efficient. Losses are less. Next, demand management is possible. You can say grid is intelligent. Why? Smart meters we are installing everywhere. Okay. Then clean power we are getting since it is a hybrid renewable systems or HRES. Okay. So we are getting which one? Clean power we are getting. So one more objective is energy storage also we are considering. Fine. Then after that we have seen fundamental application what enabled and top level. Fundamental what is enabled? Can you tell me? In the circuit level, as an electrical engineer, circuit level what enabled, what changes are done? Smart meters we are installing, gas insulated substations we are considering. Okay, in the circuit level, and one more circuit level what we are doing? We are considering distributed energy sources throughout the network, like PV integrated charging station, rooftop PVs, and bidirectional charging infrastructures, inverter structures, service protocols. Everything is comes under circuit level. Some metering, converters, any equipment or any instrument, if you consider, this comes under circuit topology. The communication protocols, wireless sensor networks, this is comes under telecommunication. Fundamental level, you are considering both smart meters, DERs, you are considering the form of PV integrated charging stations. There also converters, charging infrastructure, inverters, batteries, everything comes under circuit topology. Wireless communication, you are merging with energy network with the communication protocol. That is comes under wireless sensor network. Is it okay? Because of which is enabled is demand response and efficiency is better way we are able to integrate. This is what we have seen. After that, what we have seen? Tell me quickly. Then we have seen benefits of EVs. What are the benefits? We can save the fuel, save the money, clean air objective we are getting. So after that, we have seen different type of EVs we have seen. What type of EVs we are having? Battery enabled, then full EV, hybrid, then plug-in. Difference I told you. What is full EV? Only batteries are there. Okay, no IC engine. What is hybrid? You are having both IC engine and batteries are there. But here size of the battery is less and size of IC engine is more. So batteries get charged by IC engine. Clear? No need of plug-in. If you consider plug-in, it is also a combination of both batteries and IC engines, but battery should be bigger. Why? We are having external plug-in source is there to get it charged. So when you are having separate charging is there, it can be connected separately, parallel connection it can be connected. Plug-in can be connected in hybrid mode, can be connected in parallel mode. But whereas hybrid, normal hybrid without plug-in should be connected in hybrid mode. There are different types. Why? The battery should get charged through the IC engine, so it should be hybrid. Okay. Now, mild hybrid in the sense it is normal hybrid, strong hybrid in the sense plug. Okay. Then after that we have seen how the power consumption we have taken and carbon emissions how it is reduced we have seen. When you consider conventional, only source is IC engine, so carbon emissions are less. So carbon emissions are high, we are not reducing it. So now hybrid, if I take, hybrid is little bit reduced, but plug-in hybrid, more amount of batteries are there, more carbon emissions are reduced, full EV. So what we are getting, at least we are getting clean air objective is achieved. After that, what we have seen? We have seen charging infrastructures. So when you consider level 2 charging of AC is there, DC charging infrastructure is there. Per hour of charge, if I consider 240 volts, 19.2 kilowatt system if I take. So 1 hour of charge, how many kilometers I can travel? 95, 96 kilometers. So if I ensure 500 kilometers if I want to travel, so 5 hours at least I need to charge. If I go DC level 1 charging, 2.5 hours or 2.5 hours. If I go with DC level 2 charging, 1 hour. So where you are charging, it matters. Okay. That is about full EV. If it is a mild plug-in hybrid, it can be lesser than that. So what is the disadvantages or what are all the requirements for EV charging station? So essential elements what is required is transformers required, substation 33 by 11 kV substation required, adequate space is required, and since it is a PV integrated EV charging station, what is required? Shading should not happen. Uniform irradiance we need to provide. Okay. After that, network service providers properly we need to consider standard protocols and uniform standards has to be considered. Fine. So then after that we have seen earlier the structure was like this because of which demand response issues are there, stability issues are there. Now what we are doing? Tell me. I expect from you. So next what we are going? PV integrated EV charging station we are going. So because of which we can install more amount of power. Where we are installing? Outside the cities, national highways, state highways. So there are different places we are installing. Clear? So here it can be, I have shown like this way. As per your structure also if you see, there are also 4 panels, at least 4 to 5 panels are connected. You see there in the diagram. 4 to 5 panels are at least connected along with the charging point. So minimum of 2 kilowatt hours at least you can install. Generation is maybe Installation capacity is minimum 2 to 4 kilowatt can be installed on one unit. Okay. So that's what the advantage. Next, locations we have seen. What are the locations we are having? Residential, residential, then destination charging and opportunity charging. What is residential? If you have a single vehicle is there, which one I should go? AC level 2. If you have a fleet vehicles, fleet group of vehicles are there, DC level 1 I should go. Okay. Destination in the sense you have a where either it can be workplace or destinations. Workplace also I can go with either AC level 2 or DC level 1. Since you are having workplaces, at least 3 hours you will be there. But whereas destinations would have to go with DC level 1. Why? If you go only 1 hour will be there. Fine. Then corridor also is there. So then after that we have seen about these chargings. What is that? Residential charging, home charging, even grid also, alone grid is connected. PV with grid can be connected. PV, wind, hybrid renewables. PV, wind, battery with grid can be connected. Then after that we are having shopping complexes also we have to, isn't it? So 3 varieties. Then after that what we are seeing, these are the extension of that one only. Then common myths we have seen, facts and myths. What is that myth is? The people will say it can support only short trips, it can produce maybe more amount of which one carbon emissions will be there, which are not true. Even it is expensive, people say, but the thing is incentives are there. So now can you tell me quickly? So what we have under NEMP plan, we have considered FAME scheme. What is FAME scheme? Tell me quickly. I will stop here. Then I will go back. FAME scheme is faster adaptation of manufacturing hybrid electric vehicles. When it is started, 2011 initialized, 30 unveiled, 15 started. 15 to 19 is phase 1, 19 to 24 is phase 2. So how much it is allotted amount? 10,000 crores is allotted. First phase, 359 crores utilized. And how many vehicles? 2.8 lakh vehicles. How much fuel is saved per day? For 2.8 lakh vehicles. 50,000 liters per day. Now, second phase, how much is there? 16 lakh vehicles. First phase is 2.8 lakh. Second phase is 16.71 lakh. How much times it is? 8 times than that. Now phase 1, how much carbon emission is 1 year it is happened? Carbon emission saved is 129 million kgs of in a year. Now, you take the situation. Now phase 2, 16 lakh vehicles are the 8 times. How much fuel I can save per day? And 50,000 into 8. 50,000 into not 8, 9 it should be. This 2.8 plus is there, no? 2.8 and 16 also there, no? So how much it will be? So almost 10 times. 50,000 into 10 times. 5 lakh liters you can save with existing thing. That means dependency on the crude oil is reduced or not. The value will increase. Am I clear? Why people are going with these incentives? One more reason is there. EV they are supporting indirectly 1 crore solar PV panel, 1 crore kilowatt solar PV panels people are supporting, 1 crore houses with solar. Modi has announced that. So 1 crore houses. Each house what they are telling at least 3 kilowatt to 5 kilowatt they are telling. Every house with 5 kilowatt charging station is there. Tomorrow if you buy EV, will you buy or not? If you support PV first, you install rooftop with 3 kilowatt. With solar energy you are extracting. So anyway EV charging is easy only. People will go and have understood. So there is the schemes are both are interrelated. Okay. So there are FAME schemes are there. FAME 1, FAME 2 we have seen. Then after FAME scheme, what you have seen? Then we have discussed about which is FAME 1 scheme highest is where. So then these is. So Andhra how many vehicles? So that's what you see saving is that much. If you take this one, saving is how much you see here. Fuel say 234 models are there in phase 2. Phase 1 how many models are there? 137 models. Phase 1. phase 2, 234 models, 2-wheeler, 3-wheeler, 4-wheeler, buses, everything together, 234 models are there. And the fuel saved per day is using in terms of carbon emissions also, so much it is reduced. So we can achieve linear objective. So how much incentive amount is given? It is earlier it was 10,000, now it is increased to 15,000 from 2021 onwards. Okay. To give further push, what they have done? Buses they have deployed. To give further push, they have considered EV charging stations also. Where they have considered? It is on million plus cities, state capitals, state categories. Understood? So there are the places only they have allotted to where million plus people are there, where special category city is there, where like this one, smart city is there, where the capitals, that means more employees, where people are available, where the implementation will happen, where the deploy, where the deploy administration initially. Later they are going to extend it to other states or other cities, I can say. Fine. So this is what. Then after that, what we have seen. So total, how many buses installed initially? 5,000. So then we have seen about these things are there. Then quickly we have seen V2X topologies. We have seen after the session. So when you consider V2X topologies, what we are having: vehicle to grid, vehicle to vehicle, vehicle to load, vehicle to home is there. What is vehicle to vehicle? That is unidirectional, bidirectional. So these are the numbers, enhanced numbers. So this one. So vehicle to grid is bidirectional, vehicle to load is unidirectional, vehicle to home is vehicle to vehicle is bidirectional. So after that we have seen the structures of when grid to vehicle we have taken. This is one to one or one to many is possible. But vehicle to grid, grid to vehicle is one to many, okay. Vehicle I want to give back power to the grid. It should be many to one, not one to one. Okay. So it can be PV integrated, BES with that one can be taken. Fine. So then advantages, disadvantages we have taken for vehicle to grid, vehicle to home we have seen, vehicle to load we have seen, and vehicle to vehicle also we have seen. So after that we have seen the enabling of smart grid, smart home, and here smart building application we have seen, smart road also. So we have seen when there is unidirectional vehicle to grid and bidirectional vehicle to grid, what advantages are there? The services is reactive power compensation is there, demand response we are maintaining mainly. Through which what we are achieving, load profile optimization we are doing, emissions are reduced, losses are reduced, so efficiency is increased. The cost is minimized. That is any queries in this category. So here when you want to consider the batteries also, we are having different type of batteries are there. What is that? Electrical, mechanical, electrochemical, okay, thermal batteries are there. So we need to choose as per your application. When you are considering, what we need to see: state of charge, state of health, charging and discharging ratios, or time parameters. Am I clear? Then how the thermal cooling of the parameters are. Okay. Then the battery, how it will happen. So how the power flow happens. So this is onboard charges. When we consider, what will happen. So there is series connected will be there. Full EVs are series connected. We have seen batteries with a converter, with an inverter structure, motor control. Even when you consider hybrid systems, either can be plug-in or normal hybrid. So what we have next one is we are having hybrid structure or parallel structures can be taken. One example I have shown, just parallel hybrid structure. Okay. Then after that we have seen the flowchart for how V2G, G2V is connected. So when the V2G is connected, can you tell me vehicle to grid when it is connected? When there is state of charge is more than 70%, then only we will operate as vehicle to grid. When state of charge is less than 70, grid to vehicle it should be connected. Clear? So this is what. Then we have seen off-board, on-board charging is there. Then we are having communication protocols are there. Okay. So then there will be standards we need to maintain. Accordingly, everything will happen. So any queries in this And after there are some disadvantages of market regulations. What is the problem is uniform protocols are not there, standards are not there. So that's the reason issues are happening. Any queries in this? You understand this? Any queries? Is it understood or not understood? What is the name? You are answering everything. Very good. You're good. Seriously, you are very active. Nice. What is NEM? Can I understand you understood? Huh? NSGM? Huh? What is NSGM? National Smart Grid Mission. NEMP? National Electricity Mobility Mission Plan. What is FAME? FAME scheme. What is meant by FAME scheme? Your faculty is on relevant fast adaptation of manufacturing electricity vehicles. Right? Then in the past bit, what was there? Generation was only what it was conventional. Information flow was telephonic. Okay. In the present system, generation is happened with what extra added? Renewable added. The distribution rooftop is there. Then in the information flow is scattered. In the future smart electric grid, see outcome of your microgrid electric vehicles. If anyone asks what you learn, at least you should say no. In the future grid, what extra is there? What you are calling smart grid? You are what is this? Tell me. I know you understood. You people are okay. What is smart grid? Why you are calling it as a smart grid? Since you are using PV integrated charging stations, smart meters we are considering, then communication protocols we are considering, and we are using the data in the cloud centers we are saving it, and storage we are considering, and communication protocols we are considering. So that is the reason system is becoming smarter. Fine. Is it okay? Any queries? Then after that, in the EV, how many types of EVs are there? Full EV, hybrid, plug-in, mild hybrid, or strong hybrid will be there. Fine, no? You understand at least what it is. What is solar and paper? When can I show them, sir? Do you understand what? Can I show them paper? I can show them, no?
I support learning rather than doing why learning is a small amount of something happening. There comes anything happens suddenly. Belief is good. Until and unless it works properly. If it won't work, suggested learning will be that's what people will say rather than doing. People will say he won't learning. There is any issue happen with someone you are learning. He will say he will be learning. Fire. That's why even we also we also have basic design and so there's a chapter from basics to so here I have included even with this, from there then once conversion but one day If no queries, no, then afternoon what I will do, I will explain there are some papers are even paper writing or how to get a research paper I will tell you, how to select a paper. Either that one or some papers along with that. My PhD was probably some transaction papers are there. I will show you EV papers, how they have written, and if any permits, I will try to explain you how to write a research paper, how to select a topic, how to write like title to conclusion. How to write a research paper, what opportunities we are having. If possible, that one I will explain. Okay. Along with showing that, how to write a paper also I will tell you. Right? It is one. You can go for lunch and you can come back. Then we will see. You can announce it.
So, dear participants, we'll break for the lunch, and again we'll meet after 2.
మళ్ళీ నేను రిపీట్ చేస్తాను ఓకే నాలో సార్ ఇప్పుడు మనకి మీరు టర్బైన్ మెకానిజం చూస్తుంటే ఆ కంట్రోల్లో వాట్ హ్యాపెన్స్ బిగ్ టర్బైన్ is there when up is connected before top control there is a gear mechanism door the nearby hub also when there is a wind blades connected to the hub also there also gear mechanism is there pitch angle control another it is called pitch angle control two gear mechanism third gear mechanism is after this hub it will be connected to there is a speed control of 15 rpm only. Then again this gearbox is bigger gearbox which we control in 1:100 maximum ratio. Now frame of suppose based on wind velocity, your blade will one is the option. First option is based on wind velocity, that wind gain will better and movement will better, give the signal to the controller. Then your first thing will happen is your motor control full this body will either rotate this way or this way. That is first one as per the wind velocity. Don't worry. As per the wind velocity, the blade would rotate out. Entire structure will rotate or second one is blade also will rotate. Accordingly, the speed rotation also. Or two things. So ఆ స్పీడ్ వచ్చినప్పుడు ఏమవుతుందంటే ఏదో 1:100 కానీ ఎంత అయినా కానీ చేసి నీకు కట్టిన స్పీడ్ కట్అవుట్ స్పీడ్ అంటే వాట్ ఈస్ కట్ అండ్ కట్అవుట్ స్పీడ్ so synchronism is to maintain your generator then only then you can extract the power if you want to maintain a synchronism 4 structure if I take definitely 16 rpm if you take you should run with 1500 if I take 14 it వస్తుంది అనుకోండి ఇంకా లెస్ వస్తే కష్టం అప్పుడు ఏమవుతుంది కంప్లీట్లీ పిచ్ యాంగిల్ ఇచ్చి అట్లీస్ట్ యూ షుడ్ మెయింటైన్ 15 rpm ఇప్పుడు 16 rpm is coming then gear ratio will be rotated in such a way that to be mapped 1500. Sir, only main thing is which we need to consider is the generator should have the synchronous speed of 1500 rpm.
either gearbox you can use for ratio. Main thing is rotation of first club. Cover with gearbox that's rotation main maintenance. Second maintenance pitch angle. Worst case only people will consider the gearbox ratios, or else gearbox ratio generally people will consider normal way. The n by n1 by n2 ratio change చేస్తాం కదా ఎలా కనెక్ట్ చేస్తాం it can be connected air ratio also can be changed and minimal is first priority is the pitch angle rotation of the blade ఇది మొత్తం total nacelle rotation or blade rotation is first priority to make it synchronous. If both also not happen see if you fail it what happens you should be a synchronism not there then how the generator will work. Then that means your pitch angle is not controlled. You are asking this question in the sense your hub which is connected or blade is which is connected that aerodynamics properly you are not designed. You are talking about 1:100 or 1:90 you are also maintaining the talking. Your air controller works properly. Nacelle properly moving. Your pitch angle control properly works. There is a question of gearbox change. If you have not designed these things properly, then I have to work. Main is these two should work properly. So according to based on wind velocity, our control is massively movement as well as this one. Abruptly, if you change gearbox mechanism, it is not correct. So only movement of this one. That is 15 revolutions per minute only enough. 1:100 base ratio in the sense 15 revolutions per minute. That much also is quite possible. So for that one, you will arrange and downwind, upwind will be there. Upwind only we are considering, not reverse. You should not move full. Try to understand. Nacelle should be rotated in such a way that upwind should be taken, not the downwind. Downwind means full reverse. See, if the blade rotation is coming this way, is called upwind. It is rotating. If fully this mechanism comes this way, nacelle down sir. ఇక్కడ నుంచి గాలి వస్తుంది. ఇది ఇట్లా మూవ్ అవడం వరకు బ్లేడ్స్ ఓకే. బ్లేడ్ రివర్స్ బ్యాక్ సైడ్ నుంచి బ్లేడ్కి వచ్చింది అనుకోండి దాన్ని డౌన్ విండ్ డైరెక్షన్ అంటారు. అసలు ఎఫిషియన్సీ ఉండదు. విల్ డ్రాప్ డౌన్ టు వెరీ లెస్. సో యువర్ nacelle also will have some restriction. 360 degrees it should not rotate. మనం అర్థం చేసుకుంటారు. Nacelle rotation also 360 degrees will never happen. Slight rotation ఉంటుంది. ఎందుకు? Reason is if you rotate even 90 degrees also should not happen. Then downward wind will come. Effective area. That's what the tip ratio. How much amount of wind that is coming, how much is projecting on the blade, the effective area, how much it is there, how much rotation it is moving. But if you something area of area but you calculation power generation will be wind turbine generation. Rho A V Q. A max how much radius in the A and the rho and A density same. How much velocity is same. ఎంత ఏరియా టచ్ అయిందన్నది ఎట్లా తెలుస్తుంది? దట్ ఈస్ ఓన్లీ ప్లేస్ బై లోడ్. రివర్స్ తీసుకుంటే అవుతుంది. అందుకే 90 degrees కంటే అబవ్ వెళ్ళకూడదు. వెళ్తే డౌన్వర్డ్ విండ్ డైరెక్షన్ వస్తుంది. అందుకే ఇట్ సైడే ఉండాలి. సో అందుకనే గేర్ బాక్స్ లో కూడా లెస్ చేయండి సార్. ఈ పిచ్ కంట్రోల్లోనే వాడతాం మనం. కంట్రోల్లోనే వాడతాం.
ఎవరో ల్యాప్టాప్ కూడా వెళ్ళిపోయారు. బొకే చూడు.
ఉన్నాడు.
లాస్ట్ పోతే అక్కడ జాగ్రత్త మోషన్ చేసేద్దాం మనం. ఇది ఇక్కడ స్టార్ట్ అవ్వదు కానీ దాంట్లో ఇంకోటి 3, 2, 1. అది అలాగా తిట్టు అలాగే వెనక్కి పడతామా Okay guys, ఛీ, నిజం అనుకున్నా.
అరమాక
ముందు రండి అమ్మ, ముందు కూర్చోండి. ఏ మిగతా వాళ్ళేరి రా, ముందు రండి. ఎందుకు అంత దూరం ఎందుకు? సార్ ఎక్కడే ఉంటారు. రండి, ముందు రండి, కూర్చోండి. ఏ కాదు, ఎవరు వాళ్ళు ఇదే రండి. ఆయన మళ్ళీ వాయిస్ పెంచాలి కదా మళ్ళీ. ఫైనల్ వాయిస్ ముందు రండి. మిగతా వాళ్ళకి మెసేజ్ సంబంధించి ఫ్రంట్లో తక్కువ So, good afternoon, participants. So, we'll start the session 2 in the afternoon today. Sir, please continue, sir.
You are which year? Second year. Second, sir. See, this session we are going to see how to write a research paper and where to publish. Fine. So, so before that, this includes what is a scientific paper. I will explain you. Then after that, I will try to explain you about so what are the various parts of the paper. Okay, how to write each part of the paper and how to publish. Then concluding remarks I will try to give you. Fine. Anyone knows what is a scientific paper? Why we need to write it? You know what is a conference paper or journal paper? No, you know or not? Why people are publishing some conference papers or some journal papers? B.Tech project work, no. Generally, they will give you some papers and go through it, and you need to go through it, and you need to solve that paper, isn't it? You know, at least that. So, this semester, second semester, 2 second year, second semester, 2 they will understand. ఆన్లైన్ వేసుకుంటున్నారు చూడండి వాళ్ళకి అర్థం అవుతుందా లేకపోతే నేను టీవీ చెప్తాను వాళ్ళు వాళ్ళకి అర్థం కాకపోతే ఎస్ఏ జర్నల్ అవి తెలియకపోతే వేస్ట్ కదా Okay, fine. Even you don't know, try to understand. So be active. Right. After completion of the lecture, I will ask you the queries you have to answer. Right. You try to understand what it is. At the end of the lecture, at least with a little bit knowledge, you can go out. So what is a scientific paper is? So why we will write the scientific paper is it provides a medium or with the scientific paper we can communicate with n number of others who are working in that area. Suppose you are working on one particular research topic, what you will do? You will work on some experimentation. After doing that, you will get the results. After getting the results, you will keep those results in particular format and you will publish that paper in online through conferences or through journals. Fine. Why we are publishing that paper? Reason is through that n number of people can see. We are alive in the sense what? By seeing you, I can say that you are alive. technically you are alive or not means how people will know. Entire world should know about you. How world should know? You will be known to your classmates. Even entire institute may not know about you. Am I getting or not? So how world should know about you? Who is like about your findings? The reason is if you work on any of the concept, if you get particular results, you can keep it in the proper format, and if you publish the paper through conference or journals, the people who are working in that area can able to access the paper. Then entire world will know about you. Yes, this girl or this boy is technically working in that area. Am I clear now? If you are unable to publish, you will be limited with only this particular Vignan Lara. But by the end of final year, if you are able to do something, if you are able to publish something, then the people of electrical engineering across our entire world can understand who you are. Fine. So that's why scientific paper is, it provides a method for the people to communicate with other researchers who are working in that area. Is it clear? How many ways are there to publish a paper? We are having conference papers are there, journal papers are there, book chapters, books, letters, and patents. Fine. What we have? Conference papers, journals, book chapter, research books, letters, patents. When it comes to conferences, we are having national conference, international conference. What does it mean? Can you tell me? What is a national conference? What is an international conference? Can you guess? No, no, no. Either India or abroad, not it is. Actually, if any conference is organized, yes, we should answer. Your mom knows. So, what is a national conference in the sense? If you are, if you organize any conference without associating with any of the bodies, like suppose international, I will tell you first. When you call a conference as international conferences, if the conference is associated with IEEE, you might have heard IEEE conferences, no? Or IET, Springer, elsewhere. If you associate with any of the technical bodies, and if you organize a conference, the proceedings in the sense, all the papers will come into online. IEEE Digital Library it will come, or Springer it will come, or IET it will come. Do you understand? If you organize a conference in association with any of the bodies, IEEE, IET, Village, Springer, that paper comes in the online with DOI number they will give. That means entire world can see or not. Am I getting? What is national conference? If you are not associating with any of the body, your college itself it is organized. Participants are maybe either a college or participants are from different parts of India or other parts also, but the proceedings are not coming in online. You are not tied up with any IEEE or IET or elsewhere without tying up with any of the technical bodies. If you organize an event, even though participants are from across the world, but it is still called national. The reason is the proceedings will be published in where? In the form of book, or in the pen drive, or in the CD. Now, your research is limited to where? Within the book only. Within the book only. People who reads that book, they will only know that he has worked or he has worked. Or the proceedings will be published in only pen drive, or in the CD. Am I getting? Even though you have worked on particular concept, you have presented your paper in the national conference, the proceedings are limited to book, limited to pen drive, limited to CD. Then what can you know about you? The people don't know about you, no. But if you publish your paper through IEEE bodies, it is conducted. If it comes in the online, entire world can know, no. Am I clear or not? So international conference in the sense, if you conduct your conference in association with any of the technical bodies, the paper comes online, that is called international. National in the sense, you are not associating with any of the bodies, alone your institute is conducting just like that. Clear? Difference do you understand? Next, when it comes to journal paper, we are having research paper, review paper. Do you know the difference between research paper, review paper? Okay. research paper in the suppose review I will tell you first. What is a review paper in the sense? Last 10 years or last 50 years, what is the research is going on? On that, if anyone prepares a report, if they write a paper on particular concept last 20 years or last 50 years, this is what happening. These topologies are used or these converters are used. This is the advancement. So like that one report will be published. It is called review paper. For review paper, technical analysis will be given. That's it. What is a research paper? Research paper in the sense, by going through the review papers, understanding the concept, taking any one problem and deriving mathematically, doing after deriving mathematical equations, you have to do the simulation. After doing the simulation, if you do hardware, if you publish a paper with the help of your results, that is called a research paper. Is it clear? Review paper in the sense, a number of others publish some papers, you are writing a report on the particular papers which are being published on one concept. 100 papers you referred, you are writing a review. That is just you are doing technical analysis. Fine. When you do performance analysis, that is called a research paper. What is performance analysis? Taking a concept, doing mathematical analysis, doing simulations, taking the results, keeping it in the paper form, and if you publish, it is called research paper. Is it clear? Now, so book chapter is extended version of conference is journal, and extended version of journal is book chapter will be published. Book chapter in the sense, so you have a more stuff of more than journal paper is there. You can publish as a one book chapter. So there are book chapters also people will publish, and if you have after that even research books also people will publish. Research book and normal book difference is what can you tell me? Normal book will have a theory, some mathematical equation will be there, but whereas research books will have theories, modeling, mathematical equations, some simulations also will be there. Suppose if you take PSCAP or MATLAB, some books will be there exclusive books. Few are research books will be there, few are normal textbooks will be there. Textbook will have a data of only theories on mathematical details, derivations will be there, numericals will be there. Whereas research books will consist of what? Not only theoretical analysis, mathematical analysis, modeling, simulations, some few experiments and results also will be there. That's what research book. Generally research book people will publish after completing the PhD. People will publish after completing the research extended version of their PhD work, not the PhD work. PhD work anyway they are getting doctorate. They should not use that one to get the research book. Extended version of your PhD work can be published as a research book. Is it clear? Difference do you understand? Now, what is a letters? If I want to communicate to the paper, you are having only idea is there. Suppose new idea, you are having some innovative idea is there. So that modeling only, mathematical modeling only, if you do within 2-page report, if you submit to any of the journal, letters is only maximum 1 to 2 pages or 3 pages report will be there. So what we are doing, we are communicating to the journal with minimal results, minimum modeling details. Am I clear? Journal papers, detailed analysis will be there. In letters, within 2 pages, you are communicating to the which one editor about new innovative idea you are going to propose. Theoretical analysis, mathematical analysis will be given there. That's it. That's called letters also will be published. Fine. Then finally there is a patents are there. Patents are exclusively innovative idea if you are having. 2 types of patents are there. One is design patent, one is utility patent. Anyone have an idea what is design patent is? Suppose if I want to design a particular concept, we need to give you like, okay, one model you are designing, front view, rear view, back view, there are 6-dimensional views of that method will be given. 3D diagram of the proposed design has to be given with very basic details. If you give, that is a design patent. So getting the design patent is within 2-3 months you will get a design patent. It is very easy. Whereas utility patent is new concept has to be proposed. You have to do mathematical modeling. You have to do simulation. You have to do experimental studies. And the idea should be innovative idea you have to give, which is not published elsewhere. Clear? Journal papers are not like that. Suppose one concept is there. To that one algorithm you apply. To that one method extra you apply. You will show little bit of improvement you will show. Then it will be published as a conference or journal paper. Already one existing problem is there. To that you will apply one algorithm. You will apply some control method. You will change some controller. Then you will show little bit of improvement from previous method to this method. That way what you will get either conference or journal. But patents are not like that. Which are innovative ideas, you have to prove them in such a way that this is the innovative idea which is not published. If I take this concept, then there can be breakthrough happen in the industry oriented level you have to show. That will be high level. So getting letters and patents is a little bit of high level compared to remaining things. Is it clear? So can you tell me now how many ways? What is a scientific paper? What is a scientific paper? Method to communicate with other researchers about our findings. How many ways are there? Conferences, journals, book chapter, book, letters and patents. Fine, good. Now, here if you see, here if you observe, the conference is no a small part. Conference is a subpart of journal. Journal data is subpart of book chapter. Book chapter is a part of research book. So try to understand. 3 to 4 conferences stuff if you have, one journal you can get. 3 to 4 journal stuff is there, so one book chapter you may get. 3 to 4 book chapters together, you will get a book. Vice versa not possible. Already if you have published a book, you can't take some data and you can't publish. Am I clear? Once already if you publish a research book, from there one chapter I can't take it out, I can't publish a research. There is a plagiarism called, plagiarism will come. Already published data is there, what extra you are giving? If you have all, so how we should go? First you should concentrate on conference. You will publish, some 50% data you will add, you will go to journal paper publication. After that little bit you will add, book chapter you will publish. Then 4 5 book chapters together, book will come. Reverse, not possible. Clear? These are all are what? There is delta exchange incremental change will there. Little bit of improvement will happen here. But whereas these two letters and patents are, as I said, innovative ideas has to be conceived. Is it clear? Now, suppose individually we will see there are different types of conferences are there. As I said, national, international. Now we are going with international. Why? National you should not go. You should go with international. Why? These are associated with IEEE, IET, elsewhere, the technical bodies. Your paper comes in online. Fine. So now, again international, we are having biannual. Sari kuch antara kudane kaadu kada. Sari kuch biannual, annual, biennial conferences are there, isn't it? So what is biannual? Try to understand. Conference name will be same. Biannual in the sense every year 2 times it will be organized. Annual conference in the sense yearly once will be organized. Biennial in the sense once in 2 years. Once in 2 years. Suppose how it will be biannual or annual things are how they will say 7th or 10th biannual conference. 10th annual conference. 10th biennial conference is there. Which one you will go? 10th biannual is there. 10th annual conference is there. 10th biennial international conference is there. Which one you will go? By? Why? See, 10th biannual in the sense last how many years that conference is there? Last 5 years. 10th annual in the sense last 10 years it is there. 10th biennial means last 20 years. So which has high value? Last one has high value. And one more thing, it will be conducted once in 2 years. If I miss now, I will get opportunity after 2 years only. Whereas annual, every year I will get a chance. Mostly annual and biennial will be there. Biannual will be very minimal. Okay. So mostly annual and biennial conferences will be there. Am I clear? That means Indicon is there. 20th annual Indicon conference. This year if it is there. That means when it was started? 20 years back. Am I getting? So you can understand, okay, last 20 years it is being conducted in various parts of India. It will be conducted, not in one place. One time Hyderabad section will conduct, one time Vizag section, one time Kolkata section, one time maybe Madras section, Bangalore section. So what happened? The location is different. The conference name is same. Am I clear or not? So that means that many sections are taking it as a good conference and they are organizing. So conference location may change, indexing will be same. Clear? But compared to conference, journals has a high value. Why I will tell you. So now we are having IEEE, as I said, IEEE conferences are there, IET conferences are there, Vlits, Springer. There are different conferences are there. We are having IECon, TenCon, PEDS, PEDS. These are well-known conferences. Indicon, PES General Meeting, IACPE, and there are two conferences of national are there, which has equal value with these conferences. That is National Power Electronic, National Power System Conference. National Power Electronic is a old one, Centurion conferences. Initially, when IITs have started, they have initialized. Even though it is National Power Electronic Conference, National Power System Conference is there, but still they are tied up with IEEE. NPEC, NPSC, these are our Centurion conferences. Last so many years they are conducting. They are associated with IEEE bodies. Am I clear? Normally, national conference means they will not tie up with any IEEE bodies. But whereas electrical department, two conferences, especially two conferences are there, NPEC, NPSC, they tie up with IEEE and they will conduct all over India, even all over the world. So many professors will come to that conferences. Most of the IITian professors, NIT professors, most of the people will go and present there. That much prestigious conferences, you are. Understood my point, no? IECon has the highest value. That is a 50th conference now. 50th annual conference. That is. Okay. Is it okay? There are different conferences are there. Now, how to submit a paper to conference? So, when you want to submit a paper to your conference, any conference, the procedure is 6 months prior to the conference, call for papers will come. Suppose this is January month, no? July conference to be organized. If you want to organize conference is in July, what will happen? In January itself, notification will come. The conference is in the July. Notification will come 6 months prior only. Notification will come at least 6 months. Maybe few members 1 year before also people will go. At least 6 months prior notification will come. Once notification comes, what it will be there is call for papers will be there. Any conference if you see, there is a call for papers will be there. What is meant by call for paper? Which gives you data of in which tracks that conference being published. Tracks in the sense, what are all the areas? Is it power electronics? Is it power systems? If it is a power electronics, again sub areas are what? Like BTech is like electrical engineering, MTech is specialization will be there. PhD is a minute area people will do the work. It is not subdomains people will work. So like multi-level inverters, converters, PV systems, metallurgical algorithms, optimization techniques. There are minute areas people will work. Now in power electronics also, subdomain areas will be there. That subdomain areas will be given in the call for paper. Which areas exactly people are expecting paper from you? If power system conference is there, if you send a power electronic conference, it will not be accepted. If call for paper includes both power system power electronic papers, they will consider your paper. Am I getting or not? You may think like it is an electrical engineering. No. Actually what happened? Conferences are area specific. Few conferences are they will consider both. Some conference will have both power electronic papers, power system papers, machines, everything will be there. But whereas some conferences will be exclusively area specific will be there, they will conduct only pure power system. They may conduct only pure power electronics. See, previous I have shown. See, this is power electronics and drives conference. Power electronic drives and energy systems. Here only power electronics drives people will consider. Here power and energy drives, power electronics and drives and energy system. That means power electronics is there, energy systems are there. Okay. So Indicon is common to all branches. Indicon is common to all in the sense electrical, electronics, even mathematics, computer science, everyone can apply. Tencon also, all the branches can apply. Am I getting? Whereas PDS is exclusively for power electronics students. PDS is power electronic power system candidates. Okay. Smart grid technology. Smart grid is in the power system also only. Innovative smart grid technologies is only on smart grid technology this conference will be there. This is international conference on power systems. Only power system you can submit. This is one more is the IACP power electronic conference. So few are area specific, few are stream specific, few are like engineering domain. Am I clear? So when notification comes, you should understand what it is. What is the call for paper? What is the call for paper? Which area conference being organized? Based on that one, what is the quality of my paper we need to see, then we need to submit the paper. Am I clear? If you submit a paper, at least they will take 2 to 3 months for review. So your paper will be given to 2 to 3 reviewers. It will go. Once you submit your call for paper come, you have seen, you have submitted your paper, they will give you last date of submission. They will give you. So before that last date, you have submitted your paper. You have already worked. You are having some paper is there. You have communicated the conference paper. Is it okay? So how to write that paper? I will tell you. How to write the paper? I will tell you. Now, if you have communicated, after communicating what happened, then 2 to 3 months review process they will take. After taking the review process, what will happen? So there is review will come. Once the review comes, what happened? Paper can be, they will give you comments, paper can be accepted or rejected. Is it okay? Paper can be accepted or rejected, and even accepted also they will give you some suggestions. They will give what suggestions? So what are all the changes need to be done? So everything will be given. Fine. So you need to revise the paper as per the reviewer comments, and you need to submit the camera ready paper. Is it okay? As per the reviewer comments, you need to submit revised paper. Now once you submit the revised paper, they will not check again. It is you whole and solely. You have to revise and submit. If there is any mistake also, no one is going to verify again in the conferences. Especially once acceptance comes, the conference is accepted with some revisions. Am I clear? Getting or not? So now what will happen? You have submitted the camera ready paper. Camera ready paper in the sense in their format. They will give you some particular IEEE format. They will give you in their 2-column format. You know, no? When you prepare the reports, single column format will be there, double column format will be there. You know, Word file preparation. When you prepare any Word file, there is a single column format is there, double column format is there. So mostly double column format, 6-page format they will ask you. Okay. So now once you submit the camera ready paper, then what they will ask you to do the registration. You will pay the registration fee. Institute will give you. You need to pay the registration fee. After paying the registration fee, they will ask you to come and give the presentation. Then you need to go physically. You have to give the presentation at that place. Am I clear? When you are giving, what happened? Track wise it will be there. Track wise in the sense now power electronics also subdomain I said multi-level inverters in one track. So 10 members will be explaining only multi-level related people who are working. That area will be there. Some other converters, some other inverters. There is one more track will be on battery management system. Some other track will be other data. So try to understand. Now all the people who are working in one particular domain will be in one track. They will try to explain what work they have done. Am I clear? So once your paper is accepted, you will submit the camera ready paper. You will pay the fees. You will go physically and you will give the presentation in front of the panel. Then you will get a chance how others are working, remaining 9 members in the same domain. That is the opportunity you can get. Is it clear? Okay. After that, the proceedings will come. After 1 month, it becomes in the online. So 6 months process is first 6 months prior to the conference, call will come. After that, by seeing the calls, you are submitting a paper. Within 2 to 3 months, review will come. Once the review comes, you are revising paper and submitting camera ready paper. You are paying the registration fee. You are going physically and presenting the paper. The paper comes in the online. Is it clear? If rejected, you need to revise the paper and you can submit it to any other conference. Am I clear? This procedure is okay? No. If we go with journal papers, that is different. Journals we are having SCA, Science Citation Index journals are there. Science Citation Index expanded journals are there. There are Scopus journals are there. Okay. So there are UGC care, there are different journals are there. Fine. So but out of which the highest value will have SCA and SCAE journals. Science Citation Index journals. What does it mean? Whatever the science and engineering technology people are working, it is referred, cited in the sense referred by different people and indexed in one database. The database indexing is Thomson Reuters. SCA, SCAE papers will be indexed in Thomson Reuters database. Fine. Whatever the science papers published, which got referred and has given some particular ranking, SCA is the highest rank which is given to journals. Clear? Am I getting? Is it okay? So there is an impact factor. People will say journals. What is impact factor? Is number of papers, how many published in that area, in that particular journal. Suppose this year 100 papers were published in that particular journal. Now there are other people who are working in that area. How many members has referred that 100 papers? One paper, some 50 members referred. Second paper, some 10 members referred. Third paper, no one has referred. Maybe 99th paper, again some 50 members referred. So total number of citations by number of papers published is an impact factor. What does it mean? Impact factor 1 means at least one time people have referred all the papers. Impact factor 2 means, getting a point, impact factor in the sense the more number of people have referred that. See, don't fold your hands. What will happen? Body will present, mind will be absent. Few members are quite okay, even though they fold hands. A few members no, they're slowly going. Even though my voice is so hard, still you are sleeping in the sense. Great people. Okay. Don't fold your hands. Sit properly. At least sit straight. Very good. Is it okay? Next, we will try to see there are different type of SCA journals are there. What is that? IEEE journals, IET, again elsewhere, Vlits, Taylor and Francis, Singer, like that it is there. IEEE, again hundreds of journals are there. Based on power electronics, power systems, there are some journals are there. In power electronics, there are tens of journals are there. Power system, there are so many journals are there. IEEE transactions. There are communication, so many journals. Computer science based, so thousands of journals are there in IEEE itself. Based on power electronic, power systems, even smart grid, power delivery. Okay, there are even computer science area, electronics area, mechanics area. So all engineering domains has IEEE journals. Is it clear? Now, even IET also, not hundreds I can say, maybe in terms of tens, every stream will have at least 10 to 15 journals are there, that too electrical, electronics, computer science journals will be there, preferably of IET. Elsewhere again thousands of journals are there. IEEE and elsewhere has huge number of journals are there. Understood? What does it mean? That many papers are being published in those journals. Okay, then Vlits also more number of journals are there. Taylor and Francis also so many are there. Springer also there are again so many journals are there. Okay, that means IEEE transactions on power electronics. That is one journal only power electronic papers will be published. IEEE transactions on power systems. IEEE transactions on power delivery. IEEE transactions on smart grid. Journal of photovoltaic systems is there. Okay, so there are different journals are there. Power and energy systems is there. So different type of journals are there. Even IEEE communications is there. Okay, industry electronics journals are there. Industry application journals are there. So electric power application journals are there. So what I want to tell you is, IEEE journals again subdomain. So many journals are available. Similarly with all these journals. Clear? So now, if I want to submit it to the journal, what is the procedure? So procedure is, when you want to submit paper to the journal, you need to create an account with your email ID. You need to create an account by going into that particular website. IEEE transactions on power electronics I need to go. So power electronics website I should go. I need to create an account. How to create an account? When you are creating an account, so they will ask you which area you are working. You need to do so. Okay, these are the areas I am working. Keywords has to be given. Email ID has to be given. Phone number, other things has to be given. Details they will ask you. Okay. So you have created an account. After creating, you need to submit a paper. When you submit a journal paper, what will happen? It will be interrogated by the editor. So every journal will have an editor. So there is a chief editor will be there. Like how you have a particular college principal is there, like that for a journal there is a chief editor will be there who will looks into all the papers. Now IEEE transaction power electronics is there. Again subdomains are there. In that also again converters area will be there. Inverters area will be there. Even integration papers are there. Okay. So there are again every journal will have 5 to 6 subdomain areas will be there. Based on subdomain areas, there are associators will be assigned. One chief editor will be there. Like how we have it HODs. Similarly, there are subdomain areas will be there. So there are associators are allotted. Now associator what he will do? He is the subject expert who invites reviewers. Am I getting? So now, when you create an account, you will submit a paper. It goes to chief editor. Chief editor will assign that paper to associate editor. Associate editor will select reviewers. 3 to 5 reviewers. Now your paper will go to 3 to 5 reviewers. So this entire process within 15 to 20 days it will happen. Now, once the paper has gone to reviewer, he will review the process. Okay. So when he review the process, how difficult it is. About SCA journal I am talking, not the paid journal. So once if you communicate your paper, the work is extremely good. The work is extremely good. Quality of the paper is greater than 95%. Extremely good. Then directly accepted. That is one case. If your quality of work is not that much good, if it is 90 to 95% is good, then what will happen? You will get provisional acceptance. You will get clear. If the paper is extremely good, then you will get acceptance. If the paper is the minute errors are there, maybe typographical errors or some little bit of minute diagrammatic changes or minor changes are there, then what will happen? Provisional acceptance will come. So if suppose there are small mathematical equations wrong are there, any mathematical equations wrong, or in the simulation studies also some mistakes are there, some methodology explanations are required, people will give you even minor revision. That means quality of work is 80%, they will give you minor revision, not the acceptance. If your quality of work is only simulation you have done, you have not done the hardware. So that is called major revision. For a major revision, what happen? Major revision, if quality work is 70% something, they will give you revision, 3 months time will be given to you. Try to understand. So when you consider any of the particular journal paper, when you submit it, it can be directly accepted when quality of work is very good, or else provisional acceptance you will get if it is finally okay, some type maybe numerical errors or typographic errors are there, but you will get a minor revision when the little bit of minor changes are required in the paper. Is it clear? For that one month time will be given to you. For a minor revision, 1 month time they will give. Provisional acceptance, 1 week time they will give. And major revision, they will give 3 months time. Since why? You need to do this hardware setup. No? For hardware setup, they will give you 3 months time. It's you who has to submit. Either within 1 month are you submitting, or within 2 months are you submitting, or within 3 months are you submitting. Here, once I submitted, chief editor will decide. Associate editor it is going. After going to the associate editor, reviewer 3 months or 2 months he is taking. Few members will give in 1 month. Few members will take in 2 months. Okay, journal to journal it will vary. Once it is given, direct acceptance, no issue. Provisional acceptance, 1 week again you need to submit. Minor revision, 1 month you will take again. Major revision, minimum 3 months. Now, there is a possibility even simulations also not properly done. Sometimes they may give you reject and resubmit. There also, if topic is very good, some simulations are okay, Some algorithm changes are required. Reject, resubmit also they will give you. Sometimes that is also not good. Reject also. In this process, how much time it will happen to good SCA journal? Minimum 4 months to 1 year, based on how quality your paper is, how best your paper is, then how to get good SCA journal. Am I getting? How to get in PhD minimum 3 SCA journals required to get a PhD. Few members will get 5. How? You should know what topic you are working. Next also, next 6 months which topic I am going to extend. And it's not just in which topic you are working. That paper, where I should submit, I should. I'm having one product. I should not take it in Andaman Nicobar somewhere where the sales are not there. I should not give no somewhere where my product will be, sales will be there. There I should give no. In a similar way, when I prepare one document, when I work on particular concept, so where this are which where it suits, I should find it. Fine, understood. When I'm communicating, one more thing I should see: what is the quality of my paperwork? How, what are the quality of the papers being published in that particular journal? Of course, one journal is there. Same area, some papers might be published previously. What is the quality of the papers already published? Is my paper at least better than that it is there or not? I should understand. If better than that paper is not there, will it be accepted? It will be rejected. No. When I am communicating to one journal, I should see what type of papers being published, in which area it is published, is he accepting simulation, is he accepting experimental analysis, is he accepting review papers. So I should understand first, then I should communicate. So without doing the background survey, if I do, rejection will come, then again submit, major revision, minor revision, this much process may happen. Am I clear? To avoid that, I should understand thorough knowledge about which journal I am communicating, what quality work they are doing, what work I am having, how to communicate. Fine. So then we will see how to write a research paper. Then we will see individually. So before that, how to select a paper? Do you know? At least let me tell you how to select a paper is you are having when you want to select any of the research paper, any of the research topic if you want to select. Even for tech fest you are going, you might be going, or any conference when you are going, or if you want to do your major project, how to select a topic, that is very very important. Or what topic to be selected. First, I can go to scholar.google.com. You have a scholar.google.com. You know, there is a scholar.google.com is there. In that, you can search as a paper wise. You can search as other. Okay. So here I can show. No, it won't be connected. Okay. Later you can search scholar.google.com on website will be there. There you can search the papers as a topic wise. You can search papers will come left side. No, year wise will be there. 2004 onwards, 2024, 2025, 2023. Years wise it will come. If you select 2024 onwards, 24 onwards paper will come. Suppose initially when you want to select a topic, first you have to go through the review paper in that area. Am I clear? Review paper you should understand. Again, as a second year student, how you will know that what all the subdomains are there? You may not know. So what you can do, you can go through the profiles of some IIT professors. IIT professors are your faculty members, some university professors who are publishing that area. At least you spend some 1 or 2 hours time. You go through the profile of the people. As I said, you can open any website of some IIT. You open. There are electrical department faculty will be there. You click their profile. There are some papers are available in their area. You just randomly go through the profiles of each and every guy. Okay. You may be motivated in some area. You select, suppose multi-level power quality issues are there. You select power quality issues. You review on power quality issues to type in the Google. Scholar.google.com. You will have n number of papers will come power quality issues papers. Power quality issue means what? You are having what? There is voltage issues will be there. That means voltage sag, voltage swell, unbalance in the voltage will be there, voltage harmonics will be there. There are current unbalances are there, neutral current compensation techniques are there. There is a current harmonics are there. Am I getting? flickers. There are power quality issues you are having, voltage issues, current issues, as well as there are frequency issues are there. Now there are few papers will be on DStatCom means which deals about current issues. DVR is dynamic voltage restorer, which deals about voltage related issues. UPQC, unified power quality conditioner, which deals about both. So you will get slowly what happened. First you are downloading review paper, you are understanding what is a review, how many converters are there, or how many controllers are there, everything you will read. After reading the review paper, what you will do? You will be motivated, okay, these many converters, these many controllers are there. Now what you should do? From the motivation, what I need to write? I need to take that paper, then I need to search now. Initially, power quality issues, review I should type. Now what I will do? From there, when I understand individual topics, the topic wise I will search. Am I getting? Now research papers you will download. If you download research paper, what you will understand? Okay, which method they have considered. In the research paper, okay, previous guy, your senior or your faculty, what parameters he has analyzed. There are XYZ members are there. Suppose 100 members are there who worked in that area. So with this diagram, how many parameters they have analyzed? What are the common parameters? What are the exclusive parameters? First I should understand which system they have considered, what controller they have considered, with that what parameters they have analyzed, everything you will be able to note down. That means your research is summary of till date who are all worked, everything will come. Am I clear? When you do research, first you have to download the review paper, understand the fundamental concept. After understanding, write the motivation parameters. After writing motivational parameters, what we need to do? You download research papers in that area. From the research paper, what you will do? You will try to understand what methodologies people have worked, how many simulation papers are there, how many experimental studies papers are there. Understood? In the simulations, what algorithm they have used, in the experimental study, in what extent they have done experimental studies, what parameters they have analyzed, how they have done experimentation, what is the size of the system they have taken. To do experimentation, what are the elements required, everything you will understand. If you have that data, then if you start simulation, then it is easy. Am I clear? So for that one, what is required? You should know the topic, no? Either you want to work on grid connected PV system, you want to work on wind energy system, you want to work on wireless power transfer systems. Okay, there is electric vehicle charging topologies are there, converters are there, inverters are there. So whatever you want to do, suppose one more thing, you want to work on DC-DC converters. Let us suppose converters will be used in grid connected PV system. Converter can be used for EV system also. Suppose you are working on converters for PV system. Let us suppose how the PV is connected. PV 5 kilowatt system I have taken. PV system, then converters will be there, inverters are there, grid is there. If I understand how many PV systems are there, then different converters if I know, different inverters if I know, then if I are working on only converters, let us suppose you are taking grid connected PV system, let us suppose. PV panels are there, no? PV panels can be connected in series. Panels can be connected in parallel. PV panels can be connected in, there is a total process, that one you don't know. So there are different ways PV panels can be connected. Now PV panels, no. Then we will have it, converters are there. Whatever the PV power is there, to boost the PV power, we are having a converter is there. Now PV panel again MPPT technique some concept is there. And there are after converter, inverters are there. So now even though you want to work on converters, if you do the review on PV configurations, review on converters, review on inverters, review on MPPT techniques, what will happen? You are selecting 5 converters. You are working on only 5 converters. Now your friend is working on PV configurations. Other friend is working on inverters. One friend is working on MPPT technique. Individually people are working. After that, you will get one paper. Everyone will get one paper. Now, PV configuration 5 methods are there. Converters 5 methods are there. You both can combine and get 2 papers. To both of you, inverter have connected. You 2 together, inverter also will get one more paper. 2 together, again 3 together, MPPT I have applied. Am I getting or not? When you start a research, you should not just do the review of only converter. You should do the review of where you are applying. Am I clear? Converter for EV are you applying? Converter for PV system are you applying? If you know that, so now PV configurations, you know what are all there. What is the voltage? Converter, if I want to design, what is required? I should know input voltage, input current, percentage is full, percentage current, output, how much is required, I should know, no. Then only LC values I can design, isn't it? So, if panels are connected in series, what is the voltage? What is the current? What is the power ratio? To meet the current, voltage and power, how much amount of LC should be designed? Suppose your friend is working for 5 kilowatt system. In the 5 kilowatt system also, voltage series connected in the sense, high voltage will be there, low current. There are 100 panels are there. One panel of 500 watt. 5 kilowatt system I am taking. So even if you take 100 panels, what will happen? In series, all the panels are connected. It is voltage is added together. Current is same. That means high voltage, low current application. If panels are connected in parallel, voltage is same, current is high. So some low voltage application, high current, or high voltage, low current application, or medium voltage, medium current application also I can take. So PV is no low voltage, high current, high voltage, low current, medium voltage, medium current. Suppose you should know your friend is working on which concept. Is she working on series configured system? Is she working on parallel or low power, medium power, high power? So which rating you should design converter you should understand. If you design for that values, then you both can combine your topics project. Now your converter, what is input, what is output, if who is designing inverter, that person knows. For that particular converter output is input to the inverter, no. Who is designing inverter, that person should know what is series system, how much size they have taken, what is the converter output, then accordingly inverter you can design. Am I clear? Getting or not? So in that way, if you take the topics, if you take alone converter, only one paper will end up. If you take different converters one person, different inverters one person, different PV configuration one person, now series configured, suppose 5 converters you have designed, now you will change LC values. You will say LC values, change LC values, then what will happen? You can map with parallel converter. If you have a circuit is ready, can't you change LC values and can't you make it like mapping with the parallel configuration? Can't you map with, suppose CT converter is there, interleaved converter is there, super Leo converters are there, ultra Leo converters are there, there are different converters are available, interleaved converter is there. So you have unidirectional, bidirectional converters are available. You can choose some converters in such a way that we should map with PV configuration. Clear? So one time you will get series configured converters one paper you will get. Parallel configured converters you will get one paper. Then TCT, series parallel configured one paper you will get. That is over. Now you take series on all three, series parallel TCT with boost converter on paper, series parallel TCT with super Leo converter, all three together one more converter. Again you with, if you take inverter topologies with transformer, without transformer, H5, H5, H6, H4, here different inverter topologies are there. Now if you know different inverter topologies, if you design in line with converter, again that many combinations you can get. When you will get that many papers, when you know before what block is there, after which block is there. If you don't know, you will receive one paper. If you know what is the input block, what is the output application, then it is easy to get 3 to 4 papers. Scaling is possible in the research. You are limited with 1 to research papers. Reason is you are restricted with only your area. You don't know where to apply that converter. Is it clear? Okay. So now, how to write a research paper? I will try to give you. So when you write, each part should be divided and punctuate easily. Okay. So now, let me show you that quickly. I will go. See, there is in a paper, either conference you take, journal you take. Generally, main body of the paper will be there. Parts before the main body, parts after the main body will be there. So what is that is, what is the main body it consists of? So introduction, every paper will have introduction, theory, simulation and experimentation will be there, result discussion and conclusion will be there. This is the main body. Am I clear? So we are having introduction, theory, simulation and experimentation, then results and discussion, then conclusion is there. So what introduction says? And before the introduction, I told you main parts of body is there, before and after is there. Before introduction, what we will have parts before the main body, we have title, others details are there, abstract and keywords will be there. Is it clear? You will have a paper of title, other details, abstract will be there. After the conclusion, what we are having? Acknowledgement, references will be there. Am I clear? So I will tell you each and everything quickly. In the introduction, we will try to discuss what was the problem. In the introduction, we will try to discuss what was the problem, why you have considered this topic. To try to explain what was the problem in introduction. In the experimentation, how did you study that problem? Experimentation means how did you study the problem? Results, what did you find? And discussion, what do these findings mean? You understand? Introduction, what was the problem? You clearly explain. Then, in the experimentation, how did you study the problem? You are going to explain. In the results, what did you find the results? What parameters you have analyzed, you will give. And discussion, what do these findings mean? You are going to explain. Am I clear? Individually, we will discuss what it is. Now, how to decide the title? It is read by thousands of people. You have to give carefully. Why? Based on the type of paper you are giving, the many people, readers will not go through your paper. Reason is, a good work with improper title, it will not reach many others. Am I clear? Even the work is good, the title is improper, it may not reach the expected audience. Okay, so that's the reason we should select the proper title has to be selected. How the length should be? Length should be minimal. It should not be too short. It should not be too long. At least minimum 2 to 3 lines title should be there, not more than that. A minimum of two lines, a maximum of 3 lines, not more than that. Generally, title should be of 2 to 3 lines. So how it should be, I will tell you. There are 3 ways of writing title is there. One is general, specific, more specific. What is general in the sense? Performance analysis of PV panels or PV configurations improving efficiency. One is there. Here what it is, general idea about the research work is giving. General title in the sense, idea about your research work, what it is they will say. What does it mean? Performance analysis, only first one you see. Performance analysis of solar PV configuration for improving efficiency. You are improving the efficiency, you have considered PV panels, PV configurations. Your application is just to improve the efficiency. But which configuration you have taken? Nothing is there. One general idea, it is giving, this paper is giving general idea about your work. You have done analysis on PV configurations, through that improved the efficiency. But second one you see, specific means it gives what? Detailed view of the research work. How the title should be? Performance analysis of series, parallel, TCT configuration for mitigating the mismatch loss. What does it mean? So for this research work, they have considered series configuration, parallel configuration, TCT configuration, and how they achieved the efficiency by mitigating the mismatching losses. That means here it gives you detailed way. Okay, these many configurations the person has considered. So to improve efficiency, he has mitigated the losses. This is called specific title. The title should be more specific. What is more specific? It gives you clear and concise idea. What it modeling and performance analysis of series parallel TCT configuration for mitigating mismatch loss under partial shading conditions. What does it mean? What method you have considered? Okay, and what parameters you have analyzed, under which conditions, what methods you have considered, what controllers you have applied, okay, what parameters you have analyzed, under which conditions you have applied it. So tomorrow suppose I am having 6 configurations are there. Let us suppose I am having 6 configurations. First paper I have taken 3 configurations. Second paper I have taken 3 more configurations. If I give the first title for a first paper, performance analysis of PV configuration I have given for the first title. Next 3 more I have simulated. What title can I give? Am I getting or not? Suppose you are working on 6 configurations. First you have completed 3 configurations. Next you are going to work on 3 more configurations. So first paper I have given you solar PV configuration improving efficiency. I have given one name, general name. Is second paper when you complete 3 more configurations. Can I able to give general title? But if I give specific title, series parallel TCD configuration for mitigating mismatching loss under shading condition, if I give 3 more configuration, if I take grizzly, honeycomb, so can I able to get? Am I getting or not? Suppose anyone want to work on series configuration. Suppose you want to work on series configuration. You are typing the series configuration. All series configuration papers will come, and our paper also will come. They will refer and they will cite our paper. Otherwise, this paper will be unviewed by the people. Am I getting? So when you are giving a title, it should be more specific title should be given rather than general or specific title. Is it clear? Okay. So how it should be? Even some examples I have given. General title is FPGA control based control strategies for power quality enhancement. Here you are doing power quality enhancement with the help of some control strategies. Some controller I have used. Specific in the sense FPGA control based PQ and IDIQ control strategies for power quality enhancement. Here control is FPGA, control strategies are PQ and IDIQ. Okay, what is more specific? FPGA controller based PQ and IDIQ control strategies for so power quality I can get with the help of mitigating voltage harmonics, current harmonics, or sags. Well, anything is power quality I can say, but I specified here I have mitigated current harmonics. So anyone want to look after mitigation of current harmonics, this paper will be visible. Am I clear? So your title should be more specific. It should consist of advanced controller name, proposed method, proposed controller, what parameters you have analyzed, under what conditions. Clear? No. When you write, you should avoid some abbreviations until unless some well-established words are there, then only I should take. RS you should not. PWM everyone knows, so we can use pulse width modulation. MLI multi-layer inverters people knows. Laser, MEMS. So what are some exceptional words or well-known words? PV everyone knows. No need to write photovoltaic. Or else you should avoid the short forms in the title. Okay. So keywords how to write. Abstract is there, then keywords. Keywords how to write? How many keywords are there in a paper? At least 6 should be there. How to write that 6 keywords? What is the keywords? These are the buzzwords which are used in the entire paper. So 6 keywords should be there. How to select that 6 keywords? Tell me quickly. If you say quickly, I will leave you quickly. Or else, So keywords in the sense should be selected from proposed methodology, proposed controller, parameters analyzed, 2 at least from the parameter analyzed, and what condition you have taken, which platform you have taken. Try to understand. Keyword should be taken from the proposed method, proposed controllers, and what parameters being analyzed, under which condition you have taken. Am I clear? Suppose in the first paper, I will take series parallel TCD configurations, one keyword. TV configurations, one is keyword. Second keyword should be maximum power extraction is one keyword. Partial shading condition is one keyword. Am I getting or not? So I should consider at least these things. Parameters analyzed I have to take. Under which condition I have taken? What control do you use? Which methodology? These all should be combination of keywords or combination of everything. It is not distributed to one section. Okay. Then after that, how to write? Even this thing is not required. Title should be written in the last generally. Initially, you should have one thought of title, but you should not decide the title in the initially. Why? The reason is you don't know at the end after completion of the paper only you should understand what it is, how it has come. You should have a rough title in the mind, but finalizing should be happen in the last only. Okay. How to list the others? Listing others are highest contribution who has done. Student will be generally first other. If you are doing a simulation, modeling everything you have done, then first other will be who contributed more, that will be first other. Who contributed next will be second other. Then guide will be generally last other will be there. That's generally will happen. Okay. Here two things are there. There is a first other and corresponding other is different. Corresponding other is who has created account, who submitted the papers. That is a corresponding other. One person has to create the account. He has to submit the paper. When revision comes, it will be communicated with only that guide. Who submits the revisions, who submits the papers, and who is the person corresponding between journal editor and this paper is, he is the one. Okay. So every paper will have a corresponding author will be there. He can be anyone. But first author is based on who has done more work. But fame will goes to the first author, and even blame is there, that will be goes to the corresponding author. Corresponding author. Why? If you have done any false results, even wrong data you have kept, tomorrow if everyone sees that results, if anyone identifies you have done a wrong, that also can be published in online. So that time people will question mainly corresponding author, not the first author. If any blame comes, that should be addressed by corresponding author who is corresponding that work. Fame will goes to the first author. Fame and blame both goes to the corresponding author. For better, guide should be the corresponding author. Why? He knows you have done correct or wrong. Just to get paper acceptance, simply if you do some manipulation, some mistake you have done, you have uploaded. The blame goes to that guide, not to you. But you are also like blocked from the submission also. Fine. Okay. So you will have first author and corresponding others will be there, and rest all other others will be list. Now when you write abstract, how to write? Tell me quickly. So we are having even how to write the abstract also, that is a matters. So before that, how to write the other names? Other name should be generally, I should write the first name, then surname I should write. Why? If I write Suresh Mikli, S. Mikli will be there. The surname is unique. No other guy will have. If I write M. Suresh, Mikli Suresh, if I write M. Suresh will come. There are thousands of Suresh will be there. Am I clear? So, if I write Suresh Mikli, generally I prefer this way. Why? Suresh Mikli, S. Mikli will come in the paper. This is unique. If I write my name Mikli Suresh, like M. Suresh will come, there are thousands of people are there. So there is no identity at all. So when you write other names in the paper, you should write first name, then surname should be written. Am I clear? Is it okay? So then, so how to write the address is email ID is enough. Then abstract you will try to see. Then I will give you quickly. So the title in 2 to 3, how many? 2 to 3 lines we are completing, isn't it? Coming to the this one, others names, first other, corresponding others will be there. And now when it comes to keywords, 6 keywords are there. Now similarly abstract also, maximum of 100 to 250 words only we should consider. Journals will tell you, either some journals will ask you within 100 words, majority will ask you about 200 words. Very few journals are asking about, like, length of the particular abstract will be 250 they will consider, but mostly most of the journals 95% will consider 200 words. Okay, abstract should have not more than 200 words. That means 6 to 7 lines will be there. Fine, 6 to 7 lines are there. How to write each line we will see. One hand, abstract expands the title. On the other hand, it contracts or compacts the whole paper. In the abstract, it expands the title. On the other hand, it compacts the whole paper. So how to write the title is, abstract is the first one. Problem statement has to be given. Generally, people will start from in this paper, this is what, that is wrong. The first line should be problem statement has to be given. What is a problem statement? What is the significance of the topic? Why you have considered this topic has to be discussed. First line. Significance of the topic, problem statement has to be explained. Once it is done, then what we will take? The significance is this, or this topic harmonics is a buzzword. So what is the problem we have to discuss here? Then after that, any conventional methodologies are there. You will not list the conventional methodologies, but even though some methodologies are there, but there are some drawbacks are exist in that. So there are some gaps are there. To avoid the gaps, in this paper I have considered these methodologies I should write. Try to understand. First line should be significance of the topic, why we have considered. Second line and third line is a combination. What I should write is to address this problem, to address the above problem. So we are having, even though methodologies are existing, but these are all the gaps are existing, due to which these issues may arise. To address these issues in this paper, fourth line should be to overcome the drawbacks, what methodologies you have considered, what controller you have considered, or what, okay, under which condition you have considered has to be written. You have to state, to overcome the above problems, what you have considered you have to state. Is it okay? Some data is missed. After that, fifth line should be what parameters you have. Is it clear? The first line should be what is the significance of the topic should be written. Second and third line should be to address this issue. Even though some methods are existing, these gaps are, these drawbacks are there. To address these drawbacks, yes, in this paper we have considered this methodology, these controllers, these control strategies under these conditions has to be written. Once it is done, then what parameters being analyzed, it has to be given. Clear? With this, we have considered or we have analyzed these many parameters, names has to be given. After that, last line should be given with which platform you have worked, either MATLAB or maybe experimental studies or real-time simulation, that can be given. So, abstract, there is a way to write. Clear? Is it okay? When to write the abstract? After completion of the paper, abstract will be written. After abstract, it should be finalized. Last. Initially, you should have a thought. Finalization should be after the final draft is done only, then only you need to complete. Is it okay? Now, as I said, keywords I have already told you. How to write the introduction? Introduction is an extension of abstract. It has 6 to 7 paragraphs again will be there. How it will be is, see, first paragraph, what we have problem statement is there. In the introduction, you have to give. So, about the significance of the topic in a paragraphic wise has to be written. No one will explain. I don't know, but in school anyone is explaining how to write a paper. Getting what? Why you are looking at that? Okay, it is an extension of an abstract. Fine. It is an extension of abstract in the sense, first line should be addressed about what is the problem, what is the consequence of the problem. Suppose, what are the causes of this problem? One line you have given no first line problem statement. So here you need to give detailed explanation about, like little bit of one paragraph should be written. What are all the causes of the problem? What are all the consequences of the problem? Has to be explained in one paragraph. First line. Next, second paragraph. There are some methodologies you have taken. There are some proposed controllers you have taken. So next paragraph should be addressed about what methodology you have taken. Previously, what was there? In this paper, what you have considered? Little bit of details by citing the previous papers, methodologies. You have to write one paragraph. Next paragraph should be addressed with which controllers previously existed. In this paper, what you have proposed. So, first paragraph is dedication about significance of the topic, causes and consequences of the topic has to be explained. To meet that conventional methodology is already there, no? So first you need to talk about what methodology is available and what drawbacks are there, what gaps are there, detailed way you need to give with citing existing literature. Next paragraph should be dedicated to which controllers are existing, what drawbacks are there, it can be written. Clear? And one more paragraph should be written in detailed wise in this paper, how many methodologies are considered, what parameters you have analyzed, clear and cut you have to write. Then last one should be organization of the chapter has to be written. One paragraph should be written, organization of the paper. What does it mean? Section 2 deals with so and so, section 3 deals with so and so, section 4 deals with so and so, and finally conclusion is given in this section. So organization of the paper should be given. Before the organization of the paper, you have to give overall block diagram. Am I clear? Overall block diagram including from source to till load. Now, section 2 deals with source means the diagram people can easily understand. Which block in which section is explained, people can easily correlate when you give the block diagram in the introduction. Along with that, sometimes people will give what there is, you are having this one, nomenclature will be there, like some few papers will have more abbreviations, some papers will have more, these things are there, abbreviations and symbols will be there. So abbreviations and symbols also can be given in the introduction. Fine. Is it clear? So introduction, what we are having, significance of the topic, detailed manner we are explaining, causes, consequences of the topic, then conventional methodologies, conventional controllers, detailed way, 4-5 papers by citing you are explaining. After that, so some gaps about that one you are discussing. Then in this paper what you have taken, and then you will introduce some figure, which one? The layout of the entire your work you will give, and you will give organization of the paper. Is it clear? And every paper will have, is it okay? It will be written that one. So there are conventional methods you will take. You will take proposed method. When you take conventional method, already existing one is there. Conventional method is there, already existing. Some proposed methods are there. One conventional method you have taken, one old method, one new technique you have taken. When old method is there, already when well-known one, you no need to write again theory about too much about that conventional methods. So when you give the conventional method, you have to give just a block diagram, less amount of theory, required equations, required simulation has to be given. Try to understand. When conventional methods you are writing, required equations, required theory, and less number of maybe modeling equations what is required, then one block diagram can be given which is well known, and only some simulation has to be given here, and you have to give what is the drawback of this method has to be explained in the last. Is it okay? Since it is known to the people, but when it comes to the proposed methodology, what should be there? Can you tell me? So this is the one who what you are giving to the world, proposed method or proposed algorithm. What I should give? In the proposed methodology, you have to give schematic diagram. What is the difference, you know? In the conventional methodology, you are just giving block diagram. Transfer functions you are not explaining. Mathematical modeling you are not explaining. But when it comes to proposed methodology, this is the new data you are giving to the people. So 3 to 4 pages you have to give the data. Then how you will give the data, particular data? Detailed theory, detailed schematic diagrams, modeling some data equations should be given, and if algorithms flowchart is there, you have to, with the help of flowcharts and algorithms, it should be explained in a proper way. Clear? Is it okay? You understand? And simulation result has to be given. Then after that you have to give about experimentation section. Experimentation section. So different titles will be there. What is that? What experimentation you have done? What is the experimental work? Experimental details. Which experiments you have performed? Okay. What experimental apparatus are there? Which type of setup you are having? Which materials and methodologies you have used? Everything should be discussed properly. What type of experimentation you have done? Which experimental work being organized? And experimental details about either. Okay. So then apparatus setup should be proper. Setup in the sense, suppose you are having 10 elements are there. All the instruments should turn on. Your output diagram should be visible clearly in the DSO. DSO you will take no. Without turning on, one setup if I take photo and if I keep in the paper, people will not accept. You got that result means when they will know. When you turn on your DSO, whatever the result you kept in the paper, it should be clearly visible in the experimental setup. Then chance of acceptance will be high. Is it clear? Now, then after that, once you have done, then results how to write. So when you are writing the results, you should write processed results has to be taken, not the raw data. What is the difference between, this is the knowledge which you are giving to the entire world. So what is the processed results? Difference, can you tell me? Do you got a chance of doing MATLAB? Huh? How you are taking the MATLAB results? How you are taking? Are you using figure properties editing or snipping tool are you doing? Huh? Figure properties you are doing, no? So processed data in the sense, when you have a simulation data, what you need to do? You need to go to the figure properties, labeling of x-axis, labeling of y-axis, 2 or 3 curves are there, then you can increase the thickness of the curves. Okay, 2 or curves are there, then labeling the values with arrow marks of voltage, current and powers with different colors, different thickness. Why thickness is required? Reason is, when you squeeze it and keep it in the 2 column paste, the thickness will be reduced to 2 point, will be reduced to single. It will not be visible. When you are taking the results, try to avoid right color of yellow, other things. Why? When you take the printout, it will not be visible. Am I getting or not? So you have to take the processed results, not the raw result like print screen and keeping. Such should be avoided. Why? And one more thing, most of the papers get accepted based on how good you are representing your results. Suppose if you are very good enough, what will happen? There are dynamic changes are there. Load is suddenly applied, load is suddenly reduced. So the transient analysis also with arrow mark increasing way you can show the results. No or not, I don't know. So at least you can, the maximization can be shown when the load increase is there, load reduction is there, how fast the dampings are settled. Understood? You might have done time domain analysis, isn't it? Time domain analysis you have done, no? Control systems. First order, second order systems are there. Suppose second order system time domain analysis you have done. So there what we will do, what we will take the output. Alright, time domain analysis when you take, what we will do? When there is series RLC circuit, if you take, when there are two components are there, energy storage element. So what you will get, second order system it will become. When you have one energy storage element, it will be first order system. When you have a two energy storage elements there in the circuit, it is a second order system. When it is a second order system, what will happen? Omega n square by s square plus root of omega n s plus omega n square is there. Now what is that? Tau value will be changing. When based on the damping ratio tau value change, then what will happen? There is a time domain response will change. One time what we will take? One time will be taken for when critically damping response, when unit step response is taken. Okay, critical damping is tau equal to 1, under damping is 0 to 1, over damping is above 1. So all three can be plotted in one plot. Then how to show that? You keep the arrow mark 0 less than or tau equal to 0.72, that is under damp, tau equal to 1.32 or 1.35 over damp, tau equal to 1 critically damped. So like that arrow marks with colors you can show, or that colors you can show, that labels can be given with that names. Do you understand? And even that labeling also with figure properties times in Roman with 12 bold can be taken. You know that one, that is called the process results. When you do all the things, when any person sees, oh, this guy knows, only you have taken figure properties, labeling you have given. You have not done what is, there are 3-4 curves are there. You have not done the labeling of the 3-4 curves discrimination. One person has done that labeling also. The more mark will be given to the guy who has done that labeling, not to the other one. Got my point? No. Is it clear? Even tau value how we will decide? 1 by 2 into r into root of L by C, C by L, something you will get. You will not change LC values, you will change resistor. Why? Dampings will happen, oscillation will happen due to resistance. So by changing R value, you will keep critical damping or under damping or over damping. So now for R equal to how much this is achieving also you can write that. For which loading condition? So similarly, when you go for a research also, when you do simulations, processing data is very important rather than just getting the results and keeping there, something there. Fine. After that, so once the result is there, the discussion is the very crucial part. Why that result is like that? Why not? Why that overshoot is there? This is without compensation. Now, if overshoot is there, if I use PID controller, with the help of D controller, how much amount of overshoot is reduced? Percentage of maximum overshoot will be there, no? And what is settling time? How to minimize that settling error or damping coefficient? There is I control is there, and P controller gain I can increase, isn't it? With P controller gain I can increase, steady state error can be reduced with I controller, and the overshoot can be reduced with D. So how much percentage it is reduced and for what value it is reduced also, if you write, people will appreciate. when you write the discussion, why that curve is like this. Now after compensation, how much it is reduced from this much 10% to it has come to 2% error. How I achieved that 8% elimination, how it is happened? By adding which element it is happened, which is the parameter I have changed. Theoretically, simulation wise, if you are able to explain the discussion properly, then paper will be accepted. Am I clear? Not just dumping the results, crossing the results, how it has come, why it has come, with what value it is achieved, which controller is giving that value, I is how much error is reduced, with P how much gain is increased, with D how much overshoot is reduced, and with D what value it is reduced. Is that percentage of error is correct theoretically and simulation wise if you are able to explain that much data. That means if you understand, if you do review process, review of the paper thoroughly, if you understand mathematical modeling thoroughly, then result will speak with you. Why? Theory you know very well. Mathematical modeling if you have done for the theory, you understand how the improvement is happening. Then simulation comes. Then you will understand, oh, this curve has come because of this element. If you are able to write, then paper will accept. Or else, figure 1 shows this diagram, figure 2 shows this diagram. That will be with you only lifelong. It will never be accepted. Fine. So then after that, so what we have? There are, after discussion, there is a comparative study will be there. In the comparative study, suppose two controllers I have taken, two components are maybe two or three controllers, two or three methods I have taken. Then what I will do? I can do the comparative study. The conventional method is there as well as proposed methods are there. So if I want to compare the conventional methodologies with proposed methodologies, so I can give the comparison in the way of tabulations I can give, in bar graphs I can explain, in line graphs I can explain, pie charts I can explain. Suppose you are working on 6 configuration. In one paper I will give tabulations. Second paper I will give comparative study based on bar graphs. In another paper I will give line graphs. In another paper pie charts I will give. I should not consider every paper of tabulations only. Where is the freshness? If I write 2 or 3 papers, in one paper I can give tabulations, in one paper I can give bar graphs, in another paper I will give pie charts, line graphs, bar graphs, tabulations, differently I need to draw. Is it clear? Even diagrams also. One paper to other paper, in a fresh manner I need to redraw the structures, and I should understand when you're drawing diagrams also, you have to see how best the previous people has published, how good their diagrams are. Your diagram should be better than that. Just I will draw black and white, one line diagram I will draw, it should be accepted. No. There are 3D diagrams people used to draw with the help of smart draw software. There are visual softwares are there. You have to draw using that software, not crop and paste. Am I clear? So comparative study also can be done with the help of tables, bar graphs, line graphs. Fine. So conclusion. How to do write conclusion? This is not conclusion of the session. How to write the paper conclusion? How to write the paper? How to write the conclusion? There are two types of conclusion will be there. What is that? One is general conclusion. One is indicative. What is general? In this paper, I have considered these many methods. It is giving the outstanding performance or dynamic performance. So that is general conclusion. What is indicative? In this paper, we have considered these many methods, these many controllers, these many parameters are analyzed. With the first proposed method, I have received this much THD. With the second method, I have received this much THD. The percentage of improvement is this much. If you talk about in terms of indicative nature, how much percentage enhancement is happened, that is called indicative conclusion. Your conclusion should be indicative, not general. Okay. And when you write differences, acknowledgement is not mandatory. It's your work, your wish. Like suppose if you have utilized any experimental session or experimental setup of any other institute, you can thank them. Or any help, any other faculty help you have taken for just some part. If he is your guide, and you will give his name as one of the other. Only some part one help you have taken. You can help. You can give them acknowledgement. So it is not mandatory section acknowledgement. It's up to you. Either to the you can thank some institutions, some organizations, even some companies, some people. Acknowledgement can be given. Acknowledgement is different. Authorship is different. Authorship is given for the highest contribution. Acknowledgement is just thanking the people. Okay. Now, references how to cite is based on this. Again, papers will be accepted, rejected will happen. We people mostly forget about how to write references. What happened? You will just like that you will be. So here, at least two references should be of reference. Recent reference paper should be there in our paper. At least recent reference paper two should be there. Why? Recent reference review papers in the sense till date what research has happened, you are up to date, you are going through it. Recent review paper should be there too. And research paper should be old to new. Few 5 papers should be control method wise, some 5 papers should be controllers based, 5 papers should be that application conditions wise. So it should be combination of all should be taken from old to new. It should not be only controllers, it should not be only compensation method. Every section should have support of, that means controllers paper something should be there, composition method technique some paper should be there, control strategy some paper should be there. Understood? So everything from old to new should be there, but preferably 70% new, 20 to 30% only old should be considered. Why? Why 70%? At least your paper is, you have referred new papers and your paper is better than those papers you are telling the world. If you consider 2013 paper, that means you stop there only. You are in 2024, you refer 2013 paper and you are doing the work of when 2013 what work was done, that one you are doing today. People will not appreciate it. You can have 2013 paper. 2013, 18, 23, 24 paper is there of same area, then it is okay. Old, medium, new, how it is improved, you am I getting? So this is what the reference is. The style how we will write is, so author's name, paper title, journal name, volume number, issue number, page number, year will be written. So author's name Suresh Mikli, the paper details, then after that what we are taking, IEEE Power Electronics, volume in the sense, year wise it will come, issue in the sense, it can be monthly it will come or yearly one issue will be there, quarterly issue will be there, half-yearly issues will be there. Okay, it is 9th in the sense, it is monthly issue. Okay, so page number CS will be there. If it is a conference paper, if it is a conference, okay, book is there, book no, author's name, book title, edition, publisher, month and year. I have power quality issues, one book is there, CRC Press, Taylor and Francis. So you can give that. Conferences means author's name, proceedings, conference, that title name, in the proceedings of 38th IEEE conference of 2012 38th. Now, IECON conference will be 2024. What is the year now? 50, no? 2024, no? So now it is 50th annual. That means last 50 years that IECON conference is there. So like that we should write. Is it clear? So now just we will try to see the final one. Now can you tell me what is a paper? Scientific paper. This is not a paper. Okay, overall we will see. What is a scientific paper? Now tell me. I will leave you in 5 minutes. It is a method to communicate with other researchers. How many ways are there? What is that? So what is the difference between national conference and international conference? Okay. Okay. International conference is when you organize any conference in association with any technical bodies, proceedings will come in online. So that is called international conference. But national conference in sense you are not associated with any of the conferences. Fine. So journal paper consists of both research and what is review? What is review paper? Review is so last 10 to 50 years, what research is going on, they will do technical analysis. That's it. What about research paper? So performance analysis will be given. That means you will consider a topic, do the mathematical modeling, simulations, validations if you do, then that is called research paper. Clear? So then after that what we discussed, so how to submit the conference paper we have seen. How many types of conference papers are there again? Biannual, annual, okay, which is best? Definitely we should go with biennial rather than biannual. Then after that what we are having? We are having journals are, how many types are there? Scopus, SCI, SCIB. Fine, fine. Okay. Now when I want to communicate the paper to the conference, when it will be opened? 6 months prior to the conference it will be opened. Then what we need to do? Submission of the paper. Then review will happen. Then acceptance and acceptance. Then after acceptance, revision you are submitting as a camera ready paper. Then after that, registration and transmitting the paper. Right? When it comes to the journal, what do you do? Procedure. For journal, what to do? Create an account. Then after that, when you submit a paper, where it will go? Right. Before reviewer, where it will go? First it goes to chief editor. The chief editor will decide subject editors, that is associate editors. Now from associate editor where it will go? Reviewers. After reviewers, then they will give you reviewer comments, status will come. A status can be, what ways it will be there? Either it can be accepted or provisional acceptance can come, minor revision can come, major revision, reject, resubmit, or reject also possible. Am I clear? So in short span of time, if I want to get a paper, what to do? I should understand what is the quality of my paper, where I am communicating my paper. I should know what quality work that papers are published in that journal. I should understand the quality of my paper should be better than the paper published in that journal should have. Then only paper will be accepted. Or else blindly, if you want to communicate paper, you will never get accepted. It comes bounce back, rejected only. Clear? After that, what you have seen? The parts in the paper. What is that? Right. Okay. There are main body, parts before the main body, parts after the main body. First, title. So title should be 2 to 3 lines. Then it should be more specific. Fine. Then after that, other details should be what it consists of. First order, second order, and so on. One should be corresponding order. So he will communicate the papers. When it comes to abstract, 200 to 250 words. Good. How many lines? 6 to 7 lines. First line should consist of problem statement. Second line should be second and third. Tell me. Conventional methods and conventional array. Even your PhD scholars know they will not get this type of lecture. People struggle to get a SCA journal. You got an opportunity in second year, you are learning this, or maybe third year, I don't know. Okay. See, PhD scholars, you go and ask, what is SCA journal? Few members, you ask them, you go and ask, you will only get that answer. I'll tell you. Fine. So what I want to tell you, you got an opportunity to learn. At least you can do best. Okay. Now tell me, what next line should consist of? Conventional methodologies and conventional what type of methods, what type of controllers are there. Just at least, even though these methods are there, what drawbacks has to be discussed. Then after that, fourth line should be proposed method, proposed controller, what you consider. Fifth line should be parameters analyzed. Then sixth line should be which platform you have considered. Fine. Then after that, nomenclature consists of keywords consists of how many? 6. What it should? We should consist of what? 6. But proposed method, proposed controller, proposed methodology, parameters analyzed, Under what conditions? Then nomenclature should consist of symbols, abbreviations. When it comes to introduction, what it says about what was the problem? It is an extension of abstract. So okay, clearly you should indicate about causes, consequences of the problem. Then clearly methodology wise you have to cite and explain the conventional methodologies, conventional controllers. Then after that what I need to give? One overall diagram has to be given and one paragraph should be what? Organization of the paper should be there. Fine. Then after that, what we should give? Conventional methodologies. We have to give how much data? Diagram should be, block diagram should be given, less theory, then less number of required equations, simulation has to be given, and you have to talk about disadvantage of that method. Then when it comes to proposed methodologies, schematic has to be given. Difference you know, no? Schematic means internal structures has to be given. The person can understand that is a new thing which you are giving. That's why it is mandatory to give schematic diagrams. The mathematical modeling can be given. Even if you want, algorithm and flowcharts also can be given. Clear? Then once it is done, even if you have a proposed controllers, you can give even proposed controllers. Then about experimentation, how you will give experimentation, what type of experiment is there, what materials you have considered, what tests were performed, experimental setup, analysis. Then results, conclusion, results and discussion, how you will write, processed results has to be taken. Okay, not the raw data, processed data. Discussion should be why it has happened, how it is happened. Okay, everything has to be discussed with what parameter. Then after that conclusion should be either it can be general or indicative. It should be indicative. Then when it comes to comparative study, what we are considering in a comparative study, bar graphs, line graphs, tabulations, pie charts. In one paper you need to consider two. There is a duplication of data. Okay, one paper, one you can consider it will be fresh field will be there. In one paper you can give bar graph, one paper you can represent in terms of like pie chart for extended work, not for the same work, remember. The next is system parameters, appendices can be given. System parameters and appendices means which, suppose PV panel configuration you have taken. What is the open circuit voltage? What is the short circuit current? What is VMP? What is IMP? What is the voltage range? What is the current power we have taken? How much irradiance values are there? So there are some system parameters will be there. Any test if you do, there are system parameters, voltage, current, power ratings will be there. So that system parameters, if you want, you can give, if you wish. Then after that, acknowledgement if required. Then references. References should be at least 15 to 20 should be there. When you do, how it should be? Review. It should consist of both review papers and research papers. Review should be recent, at least 2 review papers should be taken, and research paper should be old to new. But for methodologies you have to give, control strategies you have to give, controllers also you have to give. Is it clear? Any queries? Can you tell me? Any queries in this? Huh? Do you understand? Huh? Sure. No queries. Thank you. Either fully understood or nothing understood. Huh? Understood? Sure?
Thank you, sir. So, thank you, participants, for your patient listening. So, we are closing the sessions today.
Thank you.